How many people think you will fail? Like less than 40%. Anyone in this room? Like I can see 14 people. Don't be shy. Like nothing need to be shy.
सर धीरे धीरे तो टफ होते जा रहा है सर, इन टर्म में और डर लग रहा है.
Uh, okay. So quiz 1 से quiz 2 टफ है क्या?
नहीं सर, टफ नहीं लगा मुझे थोड़ा कंफ्यूजन लगा एक्चुअली. मे बी इतना ज्यादा डेटा हो गया ना, आई मीन इतना ज्यादा कॉन्सेप्ट हो गया.
हाँ.
तो यू गाइस आर यूजिंग डिफरेंट टर्मिनोलॉजी राइट इन क्वेश्चन में. तो कंफ्यूजन लगा कि ओके वी नीड सम, आई मीन आई नीड some more in depth practice actually, numerical practice. जैसे डिफरेंट वे ऑफ मीनिंग, आपका जो सैंपल मीन, सैंपल वेरिएंस, जैसे आप यू यूज दिस टर्मिनोलॉजी राइट, थोड़ा कंफ्यूजन हो जाता सर वहां पे. जैसे आपने एरिया वाला क्वेश्चन पूछा आपने, ठीक है, तो आपने दो ऑप्शन दिए वहां पे. थोड़ा ऐसा हमने वी नेवर एक्सपेक्टेड दिस काइंड ऑफ थिंग ना, लाइक डिफरेंट. सो थोड़ा कंफ्यूजन हुआ, बट इट वाज पेपर वाज वेरी नाइस सर. अगर ढंग से अगर प्रैक्टिस करो ना, लाइक इट वाज वेरी नाइस पेपर. एंड दिस इज व्हाट वी आर सपोज्ड टू सी in Anthem also, sir.
So see, I don't know how many of you follow some strategies while you give quiz. Matlab, what is your main motto when you sit in front of exam, and how will be your mindset? Like how will you train your mind when you have to sit for some 1 hour, right? If I consider only for statistics you are appearing, so maybe you'll get 2 hours. So 2 hours ke pehle, when you enter into the exam hall, with what mindset you guys will enter? Like what will be your mindset pehle?
Like make a lot of questions and solve stats questions first.
Okay, try to attend lot of questions and solve stat questions first.
Stats first. Yeah, I always attempt stats first.
Okay. And anyone other than this strategy, like Nikhil?
Blank, sir.
Blank.
Totally blank.
Okay.
Not thinking about exam anything till the exam starts.
Okay. Anyone? Krishna Mohan or Atul, Alex, Abhishek?
I personally speaking, whenever I'm going for stats exam, right, I keep this open session you keep, right, like the mock session you guys keep, right, just 1 day before. I keep that thing on top of my mind, sir.
Okay, so you will recollect all the questions that were given in the mock.
Sir, that's what actually I do. I more emphasize on that your mock sessions. Okay,
mock and revision sessions, sir.
And sir, in my case, Suman, so what I do is once when you're sitting at your desk there in the exam center, the first thing I keep repeating to myself that roughly, okay, we have 2 hours for two courses, and then I make an assessment. Okay, maybe I'll get 120 minutes. Roughly for every question, roughly around, let's say, 4 minutes or 5 minutes. So I would generally sometimes if I don't get an answer, I have a tendency to stick on to the question. So I keep repeating, don't repeat this mistake what you did earlier terms or during this one. Don't spend more than the required time. If you can come back later, but if you're not getting it, don't get stuck with it and lose out on trying to attend another question. So I keep repeating, like I keep telling myself, don't do that mistake, because what happens is it's a tendency that like you are working out a problem somewhere and you are not getting the answer. So you try to keep working for the correct answer, or you spend more than the required time, and then you later find that you spend more than sometimes almost 10 minutes in a question. So that is too much.
Yeah.
And so I
imagine doing all that and still making some mistake and losing that marks. That's what keeps me from doing that.
Sit for one particular question. They will take one question and they will sit for some 10 or 15 minutes. And what happens is ultimately you won't get the answer, and all the 15 minutes will get wasted.
Usually in the graded assignments, the first questions are comparatively tougher than the rest, I guess. So one thing that I practice with is doing the graded assignments and I try to do the easier ones first, just to get ready for the quiz.
So just had one thought, sir. So look at the timing for one course or two course. They have given 2 hours, sir. So obviously those who are appearing for only 1 hour getting double the time. Because this time I'm just taking stats 2 and English. I'm still in the foundation because I didn't opt for English earlier. I thought I'll do it later. So what's happening is for so which means that you are cutting down on half the time, like in the sense you are not getting sufficient time for the second course, whereas for one course somebody gets 2 hours. So I was just thinking probably like what is the timing per paper? Like if it is 1 hour per paper, then sometimes they are very lengthy also. Like,
Yes, sir. He's perfectly right, sir. Because see, if it is a like 2 exam site, so 1 hour for each state site is very less time, sir. You cannot complete 22 questions, sir. Almost 20
Yes,
as an average, you can say.
There are 20 questions.
Yeah. So with that, sir,
yes,
that's because stats require a lot of planning, peace of mind, and a lot of calculations, sir. It has to be there. Until unless you know the proper way, technique, you cannot solve any question, sir. You end up wasting time, and that stress will be carry forward to next question, sir.
Okay.
And so, sir,
what I want to add something.
Actually, if I can just add, hi, this is Vasu.
Yeah. Hi.
In fact, I remember I just submitted the last question and just kind of closed, like last second. And I remember the calculation, I think 25 by 40, the last question. English was very quick, so we got extra time. I think what I realized later when I was looking at the questions was some of the questions you needn't have even done the calculations. You just kind of had the confidence and looked at it. Like I wrote on Discourse actually.
I read that post.
Yeah. So that that unit square. Later on, I realized it's unit square. So you could have just simply just it has to be half or 0.75 or 0.25 in most of the cases.
Correct.
And then the last one, which was the last but one, which was that the longevity of the devices. That also it could have spared the marginals, and there were few other questions also. It could have saved time if you had done it enough practice questions. You could easily guess the answer, like logically guess the answer, not just random guess, but logically guess the answer.
One more thing which I probably what I
so what was the surprise?
Number of questions.
Let me tell you.
Sir, for the number of questions. Hello.
Krishna, you can ask it.
Yes,
What are you asking?
So the number of questions, sometimes you feel like there are too many for the 1 hour slot or 1 hour whatever. You find as 20 questions. I mean, there should be some kind. I thought maybe there should be a rough estimate of on average student or typical person who's pursuing this course. 4 minutes maximum. We can give 4 minutes per question. Uske basis pe probably if it set up the number of questions, but sometimes it happens that you have 20 questions, sometimes 13 questions. So it's look like totally unpredictable number of questions. It cannot be too lengthy, right? So
yes. So I have one thing here to say. So you are looking at the number 20, but the 20 came from, there are subparts. Like there are in each question, if you see the number of questions, actually they are only 10 or 11.
Yes, so that's what I also want to talk
12,
about.
12, yes.
Questions were very easy, only formula based question. Some of the question may be tricky, but those are also simple.
So treat it
what I say. If someone has completed all the activities question, practice assignment, graded assignments, I don't think he will face any problem in this switch.
So once it's an human tendency, human mind tendency. Like when you see number 20 on the right or left side of your computer screen, it will look like that within 1 hour I should do 20 questions. But somewhat logically, or maybe some deeper, if you go into deeper, it is like 11 or 12 different concepts, wherein each concept we have asked one particular question, and that particular question, instead of asking it directly, we have splitted that into parts, and we have asked like first question maybe part 1, and extending to that, it is like question number 2, question number 3, and the final question we wanted to ask is the question number 4 or 3. So there
Yeah,
are
yes,
few
sir.
questions. Yeah.
Correct, sir. Correct.
So if you wanted to solve for the 4th question directly, you will go through the intermediate 1, 2, 3 questions. So your idea should be like you should solve anyway 4th question. So what if we gave you the final question itself as the main question? So the number of questions looks like only 12 questions, but for solving those 12 questions also you will take the same amount of time to solve these 20 questions. Okay.
Yes, yes.
One.
Let's
Sorry,
take the surprises.
I don't know whether we should discuss this.
Surprise.
Session,
Okay.
Sir, I have a doubt.
So the surprise is we just saw the quiz 2 result today morning. Okay.
Is it bad?
When it will be result? When it will release on our
I
portals?
guess today we saw it. So Monday or Tuesday you will get the marks and whether you are pass or fail.
What is the surprise word?
Sir,
Sir, it's surprise or shock?
Surprise or shock, surprise, everything. So here there are again, I have.
There is a lot of variation.
Yeah, see.
Variance is big,
Here
sir.
there are 90 people, right? Sorry, 39 people. So I just wanted to say one thing. None of you think that you will fail, but the pass percentage is way less than what you expect. So go back to your questions and look at the answers, whether your answers are correct or whether you gave correct.
Sir, approximately how many students were above 90?
Very less. So
Yeah, I
that
agree with you, sir. Like
I'm expecting myself as above 90, I think.
oh, above 90, is it? Okay, you know beta.
No, I was lucky because I got a lot of time from math. Otherwise, there was no way. I think I pretty much did all of them right. I mean, at least when I go back and look at the answers.
I'll give you a rough idea. How many of you know beta graph?
0 to 1.
Yes, sir. 0, between 0 and 1. Yeah.
And mean around 0.1.
So treat it like, so expand this graph. So it's like if it is 40 here, so this is somewhere, this is how the graph of your marks are. So this is the pass percentage. So this is the passing mark 40%. So above this, there are very.
And how much is it different from the quiz 1 score?
Quiz one is better than quiz 2 result. So that is what we found out.
So one factor.
Sir, hope discrepancies have been taken care, sir.
Huh?
One factor was that.
Please carry on.
Sir,
One of the factor was
Lots of questions.
Nikhil, just a minute. Nikhil.
There was a factor that quiz 2 means quiz 2 grading was made redundant. So they decided to give pro rata marks for final terms. So we calculated that quiz 2 means preparing for quiz 2 and focused on math 2 and didn't prepare on stats 2.
Okay.
Tried to maximize one subject.
Okay.
Week 11, 12 are more difficult because not difficult, but they're more conceptual.
Yeah. No, the original statistics. What we do actual. How do we test the statistics? So we are going to test the hypothesis.
Yeah, so it can be very tricky. It may not be long in terms of calculations. It can be quite tricky. So exam can be difficult.
So I am personally feeling very difficult, sir.
Okay, we will discuss those things. Maybe Sunday there is activity session, right?
Just one.
Sir?
Hello, can you?
Sir, I want to ask something.
One second. I'll just finish. Can you hear me? So that one PDF question where there is a break in the what do you say, in the continuity, like 0 to 1 and then 2 to 3, that was quite confusing actually. I ended up spending a lot of time trying to figure out what happens at that point. If that can be, if you can answer that at some point, it will be helpful.
Okay, in this session, is it related to quiz 2?
Quiz 2, correct. Quiz 2 question where there is 0 to x to 1 and then 2 to 3. That 1 to 2 is a gap, right? So that
2 by
completely
3 and 1 by 3. That's what he's trying to say. 2 by 3 and 1 by 3.
Yeah, correct. 1 by 3 and 2 by 3. That confuses
2 by 3. From 0 to 1, 2 by 3, and 2 to 3, 1 by 3.
Yeah. So there is a gap in the in the domain. So that was very confusing as to what will happen to the CDF at that point.
Okay.
Sir, I was saying something, sir. I just wanted to know.
In that question, where the CDF graph, I also have doubt in that question.
Hope discrepancies have been taken care, sir. That's my point.
What are the discrepancies? Yeah, the one discrepancy is question number 4, like MGF thing.
Correct. That is one discrepancy. Correct. And the other discrepancy is that where we are talking about that uniform distribution where the area is 5, right? And one of the correct answer is 1 by 5 where XY belongs to D. Correct.
I read this post also. You have posted.
Yes.
Options
Yes. I very much remember that this option was at number 4 in my set QPB1.
Okay.
But when answer answer key was released, then in that particular set it is sitting at number 1 and number 2.
Okay.
Yeah, so this actually happened in quiz 1 also. The answers were a little jumbled, but eventually when the results came out, I think it got like they've done the correct marking anyway. So don't worry about it.
Yeah, don't worry about it.
Basu, point well taken. But what happens when we are evaluating the papers through computer system? Then it simply matches the answer number.
No, I don't think that they will do. They will probably take care of it, because last time also I remember the same thing happened last quiz, but eventually it came out okay. So they'll take care of it. If you anyway eventually if there is a problem, you can write to them and get it sorted.
And then not only this question, and then there was one more question where we are talking about that.
In fact, multiple
CDF 1 minus FZ minus 5 is correct answer, right? And that answer is also jumbled in the same set. If it is jumbled in different set, the point well taken. But in the same set, if answers are not matching with the answer key sequence, then it's a point of concern.
See, Ganga Prasad, whatever Vasu said is true. So
point well taken, sir. Point well taken. Point well taken. I'm not arguing on that. I just highlighted this point. That's it. My job is done. I'm not arguing on that. Point well taken.
That will take care. Okay, don't worry.
Sir, I have a doubt in AQ 10 AQ. So.
Can you be a bit louder, Krishna?
Yeah. Activity question I have some doubts, sir. I want to get it clarified, sir.
Yeah, we will start. And before that, I just asked one question. What was your mindset when you enter the examination hall? See, basically, my mindset will be like at least to get 40% in each of the exams what I am going to write now. So this should be my mindset. Like, see, each paper contains difficult questions, medium level questions, and easy questions. Your target is to find the easy questions and solve it first. Okay.
Normally, our mindset will be getting something like 80 to 100%. Normally,
first target should be like this. So first of all, you need to get pass. Then you look for your score. Okay. See, I am not arguing or I am not saying this is the correct approach. But my intentions will be like
it is very correct approach actually, because we should think that first we should get the passing marks. Then we should think about. What should we have a score of?
If your initial target itself is 80%, how will you start? Whenever you see the question number 1, how much hard it is, you will try to solve this question. So you will start with the question 1 and you read the question and you think that it takes time. But as your target is 80%, so you can only leave out of 10 questions, you can only leave 2 questions, and you think that you should solve all rest of the 8 questions. So primary target. By taking the target, if your first question itself is a difficult question, what you do is you think like I should solve this question, and you know the concept and you will sit solving for it. And it may result in deteriorating your time. Maybe you will spend some 10 minutes because it is a difficult question, and what we expect that even students take 10 minutes to solve this particular question. I'm not saying difficult concept. Difficult question is nothing but it takes lot of concepts. Combination of 3 or 4 concepts will make it difficult. So you have to use all the 4 concepts and you have to compute, solve and everything. and it will take 10 minutes for you. And most of the cases, what happens is, in the difficult questions, there will be some trickiness involved, and you will end up getting wrong answer. I don't say everyone will get the wrong answer, but most of the cases it happens to be tending to get the wrong answer. So this will ruin your 10 minutes as well as the marks. And what happens, as your target is 80%, and eventually you will reach 80%, but it is not the accurate marks you will get. By losing these marks in between, you will somewhere get around maybe 40 to 50, or maybe even less. You will fall even less than 40 category. So there are some drawbacks when you go with the mindset of I should get 100%, I should get 80%, this thing. So your target should be 100, but it should be like 40%
plus 40.
Plus 40. If your target is to 80%, it should be like 40 plus 40. So first glance, within the first half an hour, so maybe you will have 1 hour for each exam, right? In the first half an hour, what you should do is you should try to get as maximum marks as possible. Like by look at the question number 1. By reading the question itself, you will get to know whether it is difficult, hard, or how much time will it take. You can assess how much time will it take to solve. And if you are unable to solve and you know the concept, flag it. So flag it and you move to the next question like this. So while moving, you will see all the 10 questions within the first half an hour, and you will solve at least some of 4 or 5 questions. 4 questions maybe. So there will be 4 easy questions. Every paper will contain easy questions. There will not be like all the 10 questions are difficult questions. So usme every paper will contain easy questions, medium level questions, and difficult questions. So your part is to identify easy questions and solve the easy questions as quick as possible. Yes. And then while you move to this 1 to 10, you will get an idea which questions are medium, which questions are. So you solved 4 questions. And remaining 6 questions also you have an idea. Out of this, maybe 2 questions are difficult, or 3 questions are difficult, and 3 questions are medium. So, and the next half an hour, you move to this next 3 medium questions and you try to solve it. If you are done solving medium questions also, then go for the difficult questions. So this approach will make you pass as well as to get good scores. So if you
now
like
I am
it,
filling
take
answers for intern.
Okay. If you like it, take it, or else if you feel your strategy is perfect than this, please follow the strategy. Okay, this is one strategy out of many strategies. Okay. So whenever I give any competitive exam, what I think is I should qualify or I should get pass. Even in my bachelor's degree or in my master's degree, first and foremost thing when I sit for an exam, my primary goal is to get passed. And I will look out for those questions and I will solve it. Then I will move to the next questions to get more score. Okay. So I just wanted to make this because when we took the feedback, many of you said that it was not easy, it was okay, and many were like giving very positive comments. But when we saw the result, it was quite opposite. So I thought this might be one reason. These are some reasons I have.
So how you will like in a stats, how how they will calculate the final score, like total score?
Sorry, that's available in the
yeah, student handbook.
Handbook.
Some handbook, right?
Because most people gave the feedback that it was very long and all, except 1 or 2 people. I when I read through it, like
lengthy doesn't mean that they will fail, right?
No, I meant lengthy in the sense that they couldn't finish. As a result, scores would be lower.
Okay, yeah. See, lengthy might tell that 100% of the paper cannot be solved within 1 hour. So maybe they can solve 60% or at least 50% within the 1 hour if they are very slow.
Yeah.
Correct.
So when can we see the when the solution for this to
I think it will get released, I guess. No, if not today, maybe Monday you will get the
Monday. Okay.
So yeah, one above on top of this, I would like to say one thing. If you like this, try to follow this approach. If you feel that you have a better idea, feel free to share it. among yourself, among your friends, and also follow that approach.
Sir, just with your approach, for interim, if I go through 9 to 12, I will get 40% plus.
Then that depends on your preparation and your mindset. That is what I'm constantly repeating. If your mindset, you should train your mindset in such a way that you should get passed first, or you should get this many marks, or your preparation should also drive you to get. So if you wish to get 100%, if you are not preparing anything,
No, sir. Personally, for my, according to my like, I have to just pass in this test.
Okay. So if your mindset is like that, prepare accordingly with that mindset. If you wanted to pass, try to get some loopholes, maybe like some easy concepts where you can understand them easily and get some good marks, and follow these revision sessions and everything.
Sir, here I just want to add on one point, sir. Here, see, as you have given the stats, okay, around you can say 60-70% people has scored the below the average or the average marks, and very less people scored the above the 90 percent marks. I mean, 90 above 90 marks. Okay, so it's very unlikely like high percentage people are scoring less marks, sir. It's very unlikely. Okay, so what I mean to say, there is something problem with the strategy of the learning also. So I understand, sir, you are given this how to score the good marks, but sir, this much of people are facing the problem, right? So there is a little problem, and something lagging is actually in the practice also, sir. Okay, I think you understand, right? So I think
I understand, but
we going
if you have followed mock paper exactly, mock paper only mock paper. If you take only mock paper also, I don't think below 40% is given. More than 40% you can see the same replica questions in the mock.
Correct, sir. It's not like, sir, but sir, do you think so? Like, if you remove 50% also, sir, at least 30% people they might have followed that the mock paper, right? It's not like that. Even them also, this is the same problem, sir. They also facing the same problem, sir. So something is the practice, sir. Is issue with the practice also. Maybe we are lacking in the all the concept properly. We can't understand. Just solving one problem doesn't give you entire perspective. About the problem, sir. We are just simply using formula and applying it. We are not understanding. Okay, what is the meaning of this simple distribution? What is the practical meaning of this thing? We don't know, sir. If you just simply change the term, right, we'll be confused. Simply.
Correct. So this is for most of the people, not only in stats, even in mathematics also. We have seen such a huge crowd. See, if Ram is replaced with Shyam, let's say, everything is common. Even then, many people think that is a new question, new kind of question. Just the name change, they think it is a new question. Am I audible?
Yes, sir.
Yeah, you're audible.
Sir, what will be the acceptable marks?
Sir, can you please speak a bit louder? Your voice is kind of low for those of us not on headphones.
No,
okay,
I think
I will be a little louder, but I suggest you to have headphones, I guess. I suggest.
I have headphones,
louder.
Okay. Sir, what are the acceptable marks for this mock? Acceptable level of marks?
50%, I think so.
Acceptable. What is acceptable mean?
Sir,
acceptable means.
My question is.
I mean passing marks, I think.
No, not passing marks.
Acceptable. Just a second.
Acceptable in the sense that the students have understood the concepts, but the formula wise and some small things are missing, and they might get some less marks. In that sense, acceptable performance expected.
Expected performance.
Yes.
Expected performance we thought was like something around 60%, 50 to 60% each one. I can just open the quiz paper and I can show you directly that if the paper is for 40, you can actually do 22 or 23 marks straight away. Nothing to think about that. It's like straight questions, use the formula, get the answer.
Yes, sir. The problem was that in the exams, the mind went blank and simple formulas we cannot recollect. Like for the MGF function, I forgot if that was minus lambda or plus lambda.
Okay.
Sir, just a quick question.
Yeah, I
Sir,
understood.
in terms of acceptable, how much time would a industry ready or a job ready candidate would take to do this paper, and how much is the acceptable marks for such a candidate?
Expected. Yeah, I'm just saying, right? See, we actually prepare.
No, I'm not talking about
according...
students who are who understood the concepts. I'm talking about somebody who is ready for a data science job as a fresher. How much time or how much marks should an industry ready candidate be taking on this kind of a paper?
Okay. So I'll just share the screen of quiz paper. You tell me how much marks. So let's do an analysis, okay?
You mean to say comparison with the outside students, sir?
Like maybe some. Okay, this is a quiz 2 paper, okay? So can you see the screen?
Yes, sir.
Yes, sir.
Okay, I will take an average polling kind of thing. Okay, this is a question on your quiz 2. Can you see the first question?
Yes.
That the random variables x and y have the following joint density. So each one of you, like, maybe can shout out how much time will you or can you take in order to solve the 1, 2, 3.
Four minutes, I think.
Yes, sir. I
Correct,
think
sir.
I had
4 to
also
5
done
minutes.
this in 4 to 5 minutes.
4 to 5 minutes. Okay, you can anyone. Chakraborty, you can also answer.
And second one also.
No. Very first question we are talking 4, 5 was most of them said.
It will vary around 6 to 9 minutes, sir, or 8 to 10 minutes. Because
Okay,
three questions are there.
But I think if we draw the graph, I think it will be less than 2.
Okay, that is another thing. So someone who are quite smart, they can do it in within 2 minutes also. I'm not talking about those people. So how many maximum? Let's take maximum of whatever you said.
Right now, maximum is coming 10 minutes.
5 minutes, I guess.
10 minutes.
5 to 6.
All three questions.
All three questions.
5 to 6 minutes.
5 to 6.
Like what? Question number 1 has 3 sub questions, na?
Okay. Yeah. Question number 1 is all the 3 sub questions. I guess everyone are
considering
all 3 and saying that it is 4 to 5 minutes. And okay, hello. I will give you 10 minutes for this.
Yes, 10 minutes.
Okay, 10 minutes. You got 4 marks. With cross checking also, like you can cross check whatever, you go outside and drink water and come. You can solve all the 3 questions in 10 minutes. How much time will you take this for second question? Okay, tell me whether first question is a difficult question or
easy question. Easy to solve.
Are there anyone who are unable to solve this particular question, or is it trickier to solve?
No. Even we had discussed x less than 2y in mock also.
Okay, mock should. No, if you haven't attended mock also, it's a straightforward question which was discussed in the lectures also.
Yes.
Okay, 10 minutes for it. Now tell me the second question. Second question is also in your quiz paper, right?
Yes.
Now tell me, is this difficult one or easy one?
No. 2 minutes. 2 minutes. 3 put together.
Easiest of whole paper.
Easiest of whole paper.
Yes.
Now just think for a while. In order to solve the 3 parts in the second question, how much time? How much maximum time you can take?
2 minutes, sir.
Yes, sir, 2 to 3 minutes.
2 to 3 minutes, max to max.
Okay, I can hear 3 minutes as the maximum time.
Yeah, 2 to 3 minutes is fine, I guess.
Okay. Now that within 13 minutes, you only said that I can solve 6 questions. So in your paper, each one of it is a question. Okay. So now that we have done 13 minutes.
Yes. Basu was talking about this one only. Yes.
Okay. Let us discuss this question itself. Okay. Now let us discuss this question, and you tell me whether this question is difficult. Okay. Let me consider it as difficult only.
Moderate. Let us take moderate.
So can we see the answer? Can you scroll down, sir?
Answer is
Yeah, second option.
Second option.
Yes. Yeah, yes. I was right in this.
Okay. So it is given. We have given you the PDF.
But somebody has to mute, sir. Somebody has to mute.
Background noise.
Mute something.
Okay. Can that guy alone mute yourself, please? Okay. So we asked you PDF. Simply you have to compute CDF. So is there anything direct you can find CDF using PDF? Did we study this somewhere? Anywhere? Nowhere?
We studied this in week 4.
Similar to PDF but continuous.
Yeah,
For
it is
this
okay, it is continuous, but don't we know how to compute CDF from PDF?
Yes.
Okay.
So I done
We
it
can
by
integrate.
observation.
We can integrate this PDF function to get CDF.
Correct. If you integrate the PDF, you'll get the CDF. How many will get convinced by the statement I have said?
It was already said by the professor sir also to pick up this particular skill, sir.
Okay, so how much time will it take in order to solve this first part alone by finding the graph of CDF?
1 minute.
No, don't say 1 minute or 2. How much time you took?
It took
I
around
done,
10
I
to
got
12
it
minutes.
I
wrong.
done it by observation really in 1 minute.
Yes,
1 minute.
I
Okay.
got it wrong, sir. I missed the interval.
Okay, you missed the interval. Okay, let's.
I
Okay,
roamed about this question, sir, because the next question is also related to this one.
Yeah,
so I'm a bit confused. Such easy kind of thing.
Okay. Okay, let's leave the third question then. Let's consider third question cannot be solvable by few of them. Like in first two questions can be solved by everyone.
Sir.
Correct? So these are two direct questions. You will take 13 minutes. Okay. You have read the third question and you have wasted 2 minutes. Let's suppose say you wasted 2 minutes and you went for the next question. So how much time will it take to solve this particular fourth question?
See, just
1 minute, sir.
as you
1
can
minute.
see,
Max to max 2 minutes. Max to max 2, otherwise 1 minute.
Okay, 2
1
minutes.
minute, sir.
Okay, you have seen the question, you read the question carefully and you
Yes,
solved
yes.
the question.
Yes.
It will take 2 to 3 minutes. Let's
Yes,
assume.
yes, yes.
Okay, 3 minutes again.
So why is this negative?
No. The answer is wrong. It is positive. Option B is correct.
Okay.
Okay. So, okay, 3 minutes. Now 18 minutes done. And do you know how many marks you got till now? 4 plus 3, 7. And plus 2, 9. So within 18 minutes, first 20, okay, 20 minutes, let's say you wasted 2 more minutes somewhere by scrolling, choosing by shuffling from 1 to 2, 2 to 3, 3 to 4. So within 20 minutes, you got 9 marks out of 40. Okay. So what that tells you?
23%. 23%, sir.
Almost equal to 25%. Correct?
Yes.
Yes.
More or less very much equal to 1/4 of the marks you got within first 20 minutes. Okay. And now let's see these questions. Question number 1, question number 2. These are some kind of
Question number 2 is a bit involved. Calculation was there. Otherwise, we have solved this kind of question. Significant number of questions we have solved like this.
Mock. This is direct replica question of mock.
Correct. Even tutorial we have solved this kind of
even tutorial.
Tutorial also.
See, these are also not difficult, but it takes some time.
Yeah, calculation is a bit involved.
Now we have 40 minutes more. Okay. Within that 40 minutes, there are 6 questions, I suppose. 6 medium level questions we have given. And you no need to solve all the 6 questions. We have to get another 15% of the marks. Or exactly speaking, you need to get 17% marks. So that means you should get 11 marks more. So it's enough to solve 4 questions out of these all 6 questions. Okay, now can you see some difference between how you solved and I am going through the paper?
Yes, sir. Can you
Yes,
scroll
sir.
down, sir?
A little bit slower.
Slow.
Okay, our estimation is 4 easy questions, including subparts. There are 10 easy questions and 10 medium to difficult level questions. So what we expect from you is out of those 10 easy questions, you just remove some 2 or 3 questions. Baki 7 questions we expect you to solve. And those 7, all the 10 questions, we expect you to solve within 20 minutes. So you only gave the maximum time, you gave it as 20 minutes. It includes working professionals. It includes all the students, BTech just pass out, just inter pass out students, everyone. So maybe they will finish before 20 minutes, but you can also finish within 20 minutes. And baki 40 minutes you will spend for the medium to difficult questions. And actually, by doing this, you will be much more confident, if you when you solve for the medium level question. Because anyway, you are very much confident that you will get 25% of the marks at least. Now your target is only getting 15% of the marks. So your mind will get peaceful as the time passes. So try to solve as many questions as possible in the start first half an hour. Then in the next half an hour, you don't feel the time constraint that much.
So let's scroll down, sir. Slightly.
See, also these questions are also not very trickier or very different questions you have never seen kind of things. These are all somewhere you have seen in either graded or practice or somewhere. No new question that you should actually spend some time and understand the question. Correct?
Yes, sir.
See the 6th question or see the 5th question. 5th question you can see, right? X be a continuous uniform random variable and y is 1 by x. So you just have to find the PDF of y. And once you find the PDF of y, for doing question number 2, part 2 of 5th question, you need to do anyway first part. Right?
Correct.
So these are combined.
So this also means that if we are wrong the first part,
then
we lost 5 marks.
Correct. See, when will you lose these 5 marks? If you are hurried to solve all the 10 questions given in the question paper. Right? So when you are solving that particular question, focus on that question. And only solve that particular question or spend time on that particular question only if you can solve. If you know halfway through and if you don't know the other half and you sit for solving, that is a time waste kind of thing. Don't do that. Okay, let's come to see why I am telling these many things is because I am pretty much upset with the result I have seen for quiz 2. So I just wanted to know what difficulty you guys faced in quiz 2 and.
Sir, we don't want you to be upset. Please give easy questions on enter.
That is never. See, if we can give easy questions, we don't get anything. Okay? We can give the easy questions and make everyone pass. But if you pass here and you will face difficulty not here, you will face more difficulty in the future if you don't understand the concepts. Okay. Let's come back to week 10.
Sir, we are going to discuss week 11 on Sunday, is it?
Yes, correct.
Sir, and please you take the classes like open sessions.
I will be coming on that Sunday also.
Yes, sir. Please take all the open sessions till the interim and revision sessions also.
Okay. I will try. See, this particular today I will take the activity questions of week 11. I will take week 12 activity. I will take.
Sir, you take the open sessions, sir.
Open sessions, huh?
Yeah, open sessions and revision sessions.
Okay.
I
I will try. I will try. I will
Getting
try.
back to my
I can't say. See, it's not in my hands. Okay. When I say I will take this session, it doesn't mean that I can take that particular session directly. So,
getting back to my question, when all the students are under preparation for week 10, what is the point of really scheduling it for week 11 discussion?
what is
And
the
solve with us is going to come on next week, is it? For week 10. There is some mix up. No, why is it happening like this? Why do we put week 11 in?
Sir, what I will also say is what he's trying to say on Sunday, we can have solve with us session for week 10, sir. And then we can
solve with us on
Sunday, and then we can start for week 11, sir.
Okay, week 11.
No, at least majority of the students would not have touched week 11, and then week 10 is pending.
Is there any week 12?
Yes, of course it is there.
Week 12 also is there.
And it also got released.
Yes, it got released also.
Okay, we will consider.
I think give more priority to week 10 instead of week 11 on Sunday.
He has a point, sir. On Sunday we can have solve with us, and then we can jump to week 11. Otherwise, week 11 in between, and then week 10 solve with us, and then again week 11 solve with us.
Okay, but okay. See, week 10 has 4 lectures, right?
Only 4 lectures. One additional lecture. One additional also is there.
Additional lecture is only for your understanding. Okay.
No, sir. I will raise a flag here, sir.
Okay.
Because if you go through the sequence, the additional lecture comes in sequence number 4, right?
Yes.
And without completing sequence number 4, you cannot jump into sequence number 5. I don't know really I don't understand the significance of shifting into additional lecture. Of course, ठीक है, question नहीं आएगा, that point well taken.
Not the question नहीं आएगा. See, if you see the week 10.4 or the additional lecture content, there actually the professor has just solved some 3 problems. Okay. Nothing related to previous or next. So he just solved 3 particular different cases of problems. Even in 10.5 also he solved the problem.
Yes, in 10.5 also he solved the problem. But if you go through the sequence, then additional lecture is part of 10.4. And the same thing had happened when we studied about MGF.
Yeah.
No problem. We can start with 10, sir. We can start.
Yeah. Okay, so why we moved that to additional content is because there is nothing. Even though if you miss that, you won't get distracted. So
that's more on the Google Colab. That's more on the Google Colab. Additional lecture is
no. 2 problems are well explained. 3rd problem is related to Google Colab. 2 problems are well explained. Even all are well explained.
Sir, we get these tables in the exam. Like p-value table, these tables in exam.
See, not the complete table, but whatever the values you require for solving problems, we will give you direct values. Okay, let's come to week 10 then. So I think in the last lecture, Nikita has explained the concepts. Let's deal with few problems. If you have any problems, questions in the week 10, so more of activity, because anyway tutorial and practice you have answers and you can go to the solution. So how many of you done week 10?
I have completed week 10.
How many of you? Yeah, Kavita. Yes, Kavita, speak up.
Yes, I have completed it.
Okay, week 10 completed, is it?
Yeah.
Okay, any doubts in week 10?
Initially I had, but then I again solved them, so it's clear now.
Nice.
It's a bit tricky though. I mean, it's difficult to remember everything at a stage. But it's interesting.
But
this collab notebook is shared with us, where in which this histograms and all these skills. Where can we get this skill from? I'm not asking about any shortcut, but can you tell me something? Where can I get this skill, making these histograms and solving? I have completed Python, but still I'm not confident in that skill.
Okay.
So I have a query.
Yeah, Krishna.
It's a AQ activity question 10.1, sir. So can we open it or can I share the screen?
Okay, shall I share the screen of it?
Yes, sir.
Okay, I'll just share. Just a second.
Are you going to answer my question, sir?
Yes, yes. So, frankly speaking, even I am not that pro or what we say, that expert in using Colab. Okay, even I am in the learning stage of Colab. So what I do is basically whatever professor has explained in the lectures, no. So I don't know what is Python. Okay, I never saw that. I saw the name Python, but I know only Python is like some snake, not as a
Have you
program.
shown? Have you seen that?
Which seen what?
Have you seen Python?
Snake, huh?
Uh-huh.
In Jew, maybe. So yeah, so what I do personally is
But sir mentioned that this is very important skill to get.
very
What
important.
about that? Very important skill to if you
Yes, yes, yes,
changing.
yes. See, knowing this collab and see, every time you can't compute with hand.
Total MLP is dependent on that one only.
So what I do personally is, in order to gain more knowledge on this collab, you just play with it. Like whatever you know, just put it there and play with the data. I usually if I wanted to learn new things, this is what I follow. I repeatedly use them so that it get used, like it gets used to me.
So basically, it comes with time actually.
Yeah.
Right?
So whenever you get time, just open the collab sheet, and whatever you learned so far, you try to code something. Like there are many formulas, right? For standard deviation or whatever for distributions. So you can't remember everything every time until and unless you repeatedly use it.
Okay, sir. I get it.
What I do.
Sir,
Yeah.
excuse me, sir.
Hmm.
Sir, can you do the brief summary of the last lecture, sir, of the week 10 model estimation, sir?
Model estimation of few problems, right? These are only problems.
Yeah. Yes.
Okay.
Sir, I'm just
yeah 10.1. Let's start with 10.1. Okay.
So here, right from the
Please
beginning,
also explain some concepts also.
Okay, well.
So in 10.1, actually, when I was going through these two questions, question number 1, 2, and 3. So the first, the distribution, I guess, is it referring to the same thing, because we don't have for the Bernoulli P distribution uniform, that is discrete 0.3 and 0.7 values, but the probability is not given, sir. So how do we, if the
probability of which is not given?
For 0.3 and 0.7, what are the probabilities that it takes 0.3 and 0.7, right?
0.5. Uniform.
Okay. You'll have to assume as 0.5, is it?
Not assume. Uniform distribution has equal chance of probability for equal values.
So we'll take it as 0.5 and then compute these posterior mode.
Yeah. It was straight away, whatever the lecture does, you do the same thing.
Okay. For the second, I think a conceptual mistake I did. So I'll take it as 0.5. In the case of question number 3, here it's quite clearly given, right? It's a Bernoulli P with the probabilities given. So like to that extent, like we can use the P straight away from here, right? The only difference between the first one and first, second, and third is the probability.
Maybe the first part of the lecture focuses on this uniform. Maybe the values are different, I guess. It's like 0.25 and 0.75, right? In the lecture, it was
0.25
and 0.75. We just change that 0.25 to 0.3 and 0.725 to.
And one more thing, I just got it when it was pointed out that you need to take it as 0.5, probability as 0.5. Each of them is 0.5. Okay. So posterior mode, I got a bit confused from what is the equation for that? Sir? I just don't seem to recollect.
4.
No, question 1 itself, posterior mode.
posterior mode.
Yeah,
See,
something like argmax something. So I was just
here,
confused on that.
here we are asking posterior mode means which probability has higher chance of occurrence.
Yeah.
The probability that P takes value 0.3 given the samples is higher, or probability that P takes value 0.7 given the samples. So which one is higher? That will be the mode, posterior mode.
So one actually is here. If you look at the samples, one is occurring 3 times, right? Like, do we reason it out that way?
No, not that way.
No.
It's actually the lecture. I guess the answer is either of it, 0.3 or 0.7, depending upon the probabilities. So posterior mode, if you check the answers also.
So both have the same probability, right? With 0.5.
That is prior, right?
Mm-hmm.
So I think so. I will quickly summarize what week 10.1 says. Okay, lecture 10.1 says. So we know till week 9 we have seen this is called frequentist estimators. So what are these? There are two estimators we have studied. One is MME and one is maximum likelihood. So these estimators, what it does is it treats estimator as a constant. So we are trying to estimate the distribution. So there is one distribution and parameter of the distribution is maybe theta. We are trying to estimate this theta by considering this theta as a constant. So fixed constant, we treat it as a fixed constant, and we will try to estimate this theta. So this is actually happens in this frequentist estimators. Okay, whatever method of moment estimator does, or whatever maximum likelihood estimator does, we actually treated this theta as a constant, and we found that we estimated that theta. But there is a new guy called Bayesian. What he does is, so this is a new type of estimator for the parameters. In this particular case, we actually treat this parameter as a random variable, and by treating this as a random variable, if you treat this as a random variable initially, this will have a distribution. So every random variable will have a distribution, right?
Yes.
So this particular distribution, we call it as prior distribution. Okay, prior means previously, initially, before. So these are some synonyms of prior. Prior means before the computations or before we see the sample.
Yes.
Okay, that is what prior distribution is. See, prior distribution, yeah, anyway, what we are talking is we treat this theta, whatever the parameter is there, we treat that parameter as a random variable. Once if it is a random variable, each of the random variable will have a distribution. So maybe this theta can take, if it is Bernoulli, this particular theta takes values in between 0 to 1. So probability of success is in between 0 to 1, right?
Yes.
So now this theta can be anything in between 0 to 1. Correct? So it's not fixed now. It's not a constant now. It's actually a random variable that takes values in between 0 to 1. So now this particular thing is a distribution. And this particular distributions are prior distributions. So whatever we know priorly, before whatever we know, we assume them as a prior distribution. So these are assumptions we take. By looking at the data, by taking before taking some samples, by looking at the data roughly, we actually give some distribution to our parameter, some distribution, some random distribution. Some may take it as a uniform, some may not take it as a uniform, some may take different distribution, some may take it like normal, some may take beta. So whatever they like, they will take it as a prior distribution. So this is called prior distribution. Prior distribution is in our hands. So however I like, I will take it. By looking at the data, however I like, I will take it. So these are called prior distributions. So once you have the prior distributions, then we will see a sample. So some small sample out of the distribution. So sample can be, so in the lecture itself, sample was like 1 0 1 1 0, something like 5 samples I have seen. Okay, out of, maybe our experiment is like a coin toss. Okay, coin toss, and you have seen head in the first time, tail on the second time, head and tail. This is how it is. Or let's take the example of the activity 11010. Okay,
Yes,
these
sir.
are the samples you observed. Initially you thought something for this theta. What you thought? What you thought is my P is uniform between 0.3 and 0.7. So this is your prior, okay, this is your prior distribution for this parameter P. Are you getting anything?
Yes, sir.
Yes. Can you
Yes,
repeat this last part, please? This Bernoulli P, what you wrote, the P in circles.
Okay, we want to take samples from unknown Bernoulli. Okay, Bernoulli P. And initially in week 9, what we did, we expected this P to be a constant, and we estimated P, correct, P hat of MME. We have estimated, saying that if you see the samples, so if you sum the samples and divide it by n, that is the best estimator for P. So this is what we did in week 9. Correct, or
Yes,
or
sir.
you forget about week 9?
Yes, sir. MME,
and P hat ML is also maximum likelihood, also is something
same.
Same
By
thing?
n.
Okay, you got the same thing. Okay, so both are actually constant. So these are values. Directly you'll get some value. If you know, if you see the samples x1, x2, x3 and so on to xn divided by n, this is actually a value, constant value. And this is the best estimate. We say this is the estimation using method of moments estimator and maximum likelihood estimator. P is actually some value 0.3 or 0.2 or somewhere. So that is what we did. By taking P as a constant, we estimated P. But here what happened is, we are not taking it as a constant. We said it is a random variable, and how that is behaving is our assumption. So this is what we said. So it is, this particular P is a random variable, and P follows uniform 0.3 comma 0.7. So this is the prior distribution. So maybe from past experience, or maybe you have asked one expert, so just give me some distribution to start with. So maybe he suggested you to take P to be some uniform between 0.3 and 0.7.
So we can take anything. It can be Poisson exponential.
It can be Poisson exponential,
normal.
If prior distribution, we will give you the prior distribution anyway. If we didn't give, so best way to take is like flat uniform.
Correct.
Uniform is the best thing to take and move on. Okay, so this is the prior distribution we thought for P. But after you just took the experiment and you just throw the coin 5 times, and you have seen head and tail, head and tail. Now after observation, what you have to do is, so okay, I observed these things, can I improve my prior distribution, is what we do in this Bayesian estimator. What it actually does is, it actually improvises your prior distribution by looking at the samples. Okay, so you look at the data, and by looking at the data, what you do is you give some distribution to your parameter, and that data you take it follows something, some distribution, and with unknown parameter. And what we do is we actually fix some distribution to the unknown parameter by taking it as a random variable, and then we observe to see, then randomly collect few samples from the data, And after you take samples from the data, by looking at the data, now these samples, we will improvise our prior distribution and we call it as a posterior distribution. By repeatedly doing this, we will we will make better and better distribution to our P. Okay.
So sir, so here the parameter P, Bernoulli P, so we will be right in assuming that okay, P and 1 minus P, that is P is like okay, the event is occurred. So that's how we are going to assume and start working on it, right? P is for positive, like the event you are defining the event to have been occurred, right?
Okay. Now how do we compute is what in the lecture it is given. So actually what it does is, so P is actually uniform 0.3 to 0.7. Okay. So that means probability of getting P as 0.3 is 0.5 and this 0.7 is also 0.5. So this is prior distribution you have. Once you observe the samples, now you have the sample with you. So I say this is just the term denotions we use. So capital S denotes x1 taking 1, x2 taking 1, x3 taking 0, x4 taking 1 and x5 taking 0. So this is the sample. Okay, capital S denotes this particular sample. Now what we wanted to find is probability that this particular P takes value 0.3 given that sample is given to us. Now you observe the data and now you are interested to compute the probability that actually P takes. So if you are confused with probability P and this P, you can take anything like say theta. So this theta, and you say theta is uniform. Now what we are interested to find is with what probability or how much chance it has that theta actually takes 0.3 when I observe these samples. So before it is like 0.5 and 0.5, has it changed or it is same as 0.5 only is what we observe by looking at the data. Now that the samples are given to you, what is the probability that theta takes 0.3? So this is a conditional probability. So using Bayes rule, you can actually write it like this.
May I request you to repeat the last bit wherein you explain what exactly happens in the 0.5 and 0.5 again? We start off with a uniform distribution on 0.3 and 0.7 of the probabilities is what it is, correct?
Yeah, this is our assumption, prior assumption.
Correct.
Prior assumption, what is our prior assumption is this particular theta has equal chance of taking 0.3 and 0.7. So it is between uniform 0.3 or 0.7. Either theta can take 0.3 or theta can take 0.7 with equal chances.
Okay.
Is what our assumption is. Okay. Then what we did is we observed some samples, 5 samples, and it turned out to be like this 1 1 0 1 0. Or let's say you are tossing a coin and you observe that chance of first toss you have seen head, second toss you have seen head and tail. And this particular theta denotes the probability that it takes head. Okay. Initially what we expected is either it has out of 10 tosses it can only have 3 heads or it can have 7 heads with equal probabilities. Like getting 3 heads and getting 7 heads have equal chances is what our assumption is.
Here is where I was having trouble. When we say uniform, we say equal chance of the event happening.
Yeah,
now it seems like there is a event itself is mounted on something like there's a 0.3% chance and 0.7% chance. So how do I read this? Like
how do you read this?
There's a 0.3% chance of like there's a uniform possibility between 0.3 and 0.7 is what we are saying, correct? Yeah. But what does 0.3 and 0.7 represent? Whether it is a possibility of a 1 or a 0. Am I right?
Possibility for 1.
0.3 and 0.7 are values.
Value of theta. So this particular theta. So either it is Bernoulli 0.3 or Bernoulli 0.7. But our assumption is Bernoulli 0.3 or Bernoulli 0.7, it has equal chance of having 0.3 and 0.7 as value for theta. So what theta is the parameter for Bernoulli, right? What theta represents? Is it success or failure?
It's success.
Success.
Yeah.
So we are saying that probability that getting success can be 0.3 or 0.7 with equal probability. So understand this.
Okay.
Sir, can I intervene over here, sir? We are fed up with the heads and tosses kind of thing. This is the rainy season. Let us take these 0.3 and 0.7 as the 1-0, 1-1-0-1. It's rained in the morning, rained in the night kind of thing. In a 5 consecutive instances.
Okay.
So
okay.
now, can you take it this way, sir? Then it will be easier for us to understand and assimilate.
So what if it is rained on morning and evening?
So if it is rained, 1. If it is not rained, it is 0. Let us say like that. And then, the expectation what we are having on 0.3 is according to our previous experiences, right, sir?
Okay, maybe it is 0.3 and 0.7 given. Maybe you are confusing there. Maybe you can take this as 0.4 also. So you don't know which one is the correct one, but you are pretty much sure that either it is 0.3 or 0.4 with equal chance. Probability of success.
So can you take the same values and complete the base formula?
Yeah, I will go to there. See, solving a problem is not our idea. Understanding the problem is our concept. Our main intention should be like, how do you understand the concept? So okay, maybe he said whatever he said, let's take it in that way. So let's suppose say in a particular day, if it is rain, then I take my random variable value as 1. If it is not rained on that particular day, I will take it as 0. Okay. From the past data, or from in summer season, it won't rain that much, right? So you will get 0, 0, 0 and somewhere 1 on one particular. And in winter season or in rainy season, you will have more rains daily. So when I collectively look at the data, what happens is, if I look at in a whole year, then if I compute, if I see the theta is sometimes, that means probability of happening rain is sometimes like 3 days in some 10 days, and sometimes it's like 7 days in some 10 days with uniform probabilities. Did you get what I am trying to say?
Can you please? Yes.
One addition, sorry. 0.3 and 0.7 doesn't have to add up to 1. It could be 0.4. It could be 0.4 and 0.5. Just basically choices of the parameter.
Choices of the parameter, correct.
Correct, sir, correct.
Okay. It's no need to be 0.3 and 0.7. That is what I said. It can be 0.4. See, sometimes you are not convinced yourself that it may be 0.3 or 0.4. But I am sure that it is in between 0.3 and 0.4 with equal probabilities.
No. The reason I mention it again is because there could be some confusion, because if it's adding up, one is P, the other is 1 minus P. That's not the case. This is P, then the complement is 1 minus P.
These are values of theta which we are assuming. These are values of theta.
These are assumptions. So whatever you made is a valid point also. So sometimes when we see 0.3 and 0.7, as it is adding up to 1, many people will think that one is for success and one is for failure.
But most examples it's adding up to 1.
Yeah, but that's not the case. Okay. So here, when I am tossing a coin, let's come to the coin toss only. In my past experience, I know that if I toss 10 times, I will get 3 times head or 4 times head. But I forget, but I am sure that for every 10 tosses, either 3 or 4 times I see heads. my probability of success is in between 0.3 and 0.4, but I'm not sure which one is correct. Now what I do is I take the coin and I take initially my prior assumption, I take it as 0.3 and 0.4 with uniform distribution. Either theta can take 0.3 or theta can take 0.4. Okay, with equal probabilities. Now what I do is I toss the coin 5 times. But I observed, this time I observed 3 heads and 2 tails like this. 1, 1, 0, 1, 0. By observing this, I can see that I got 3 heads and 2 tails. By observing this, can I conclude anything? So is my prior assumption is correct that it is in between 0.3 and 0.4? And which one, after observing the samples, which one is the better one? Or apart from these two, is there anything new so that I can improvise my prior distribution? So that is what we do. So it's not about 0.3, 0.7. Here also you can say if it is 0.7, you treat it like this. You toss the coin, but you forget whether it is heads or tails. So you know that you have seen some out of 10 tosses, 3 are of heads and 7 are of tails, but you are confused with head and tails. You may think that 3 are tails and 7 are heads, but you forget whether which one is dominating. So whether heads are dominating or tails are dominating, you forget. But you know that out of 10 tosses or repeatedly tossing, for every 10 tosses, only 3 of one type and 7 are of other type. So in order to conclude that, what you do is you take the samples. Once you take the samples, 5 samples, you toss the coin 5 times now. After looking at the data now, you improvise your prior assumptions. You improvise your distribution, and we call it as posterior distribution. So how do we find that posterior distributions is this? So what is the probability that, so this is the posterior distribution. Theta is equals to, theta takes actually 0.3 by observing these samples. When I observe this sample, given that this sample, what is the probability that theta takes 0.3? It is actually using Bayes rule. It will turn out to be correct. Bayes rule, simple Bayes rule.
Yes, sir.
Yes. Yeah.
Okay, so the same thing. So now you know this. So what is this? Theta is equals to 0.3, and what is the probability that happening this S event S? So what is this?
When it is 1, then we have to take 0.3 and then multiplied by the. Correct.
Correct?
Yes.
So it is a product of, this is somewhat like
all the probabilities.
Likelihood.
Yes.
No.
Yes.
Yes, sir.
Yes. Okay. So you know likelihood function, right? This is what it is. Product of distributions of the sample. Just go back to the likelihood function and see. This is what likelihood means. So it's just the product of this. So probability that x1 is 1 times probability that x2 is 1, probability that x3 is 0, x4 is 1, and x5 is 0. So we know that theta is 0.3. So probability that x1 is 1 is 0.3 times 0.3 times 0.7. If If it is 0.3, failure is 0.7. So it is like 0.3 whole cube into 0.7 whole square. Okay. So this we got as 0.3 whole cube into 0.7 whole square. So what is the value of this? Probability that theta taking value 0.3.
0.5. 0.5.
So our prior assumption is theta is uniform between 0.3 and 0.7. So the probability that theta takes 0.3 is 0.5. So what is P of S then? So what is the probability that
Total probability.
it takes this? So what is the probability that x1 takes 1, x2 takes 2, sorry, x2 takes 1, x3 takes 0, x4 takes 1 and x5 takes 0. So what is this probability?
1.
1.
No, 0.3 square. Sorry, 0.3 cube and 0.7 square.
So for finding this, so you need to know what theta is actually. So this is basically theta cube times some 1 minus theta square. If you know the theta, if theta is constant and it takes only one value, this is what it is. But it is not here. Here theta actually uniform 0.3, 0.7. So it is somewhat like P of
0.3 cube.
huh?
0.3 cube.
Law of total probability.
Yes, sir. 0.7.
Okay. So this we know. This we just computed here.
Yes, sir. 0.3 whole cube.
So 0.3 whole cube into 0.7 whole square into what is this
0.5
probability? This is 0.5 plus
plus
if it is 0.7, it will be like 0.7 whole cube into 0.2 whole square. 0.3 whole square.
0.3, yes, sir.
Into
Into
0.5.
3 success and 2 failures I have seen.
Yeah.
Here the
Yes,
success
okay.
is 0.7. Probability of success is 0.7. So 0.7 whole cube into 0.3 whole square into 0.5.
So can you scroll up a bit, sir, for the earlier step? Just a little bit more. The previous, the previous page, the base formula base. Yeah. So here, actually, the Bayesian probability. So probability S given that 0.3. Okay, sir, and into probability theta equal to 0.3. So how do we arrive at the first terms, like probability of S given theta is 0.3? That I didn't get it. Like,
okay. So given that theta is 0.3, okay.
yes, sir.
Now, if it is given what it is, our samples are coming from Bernoulli 0.3. Correct? So theta is given to us. Theta is 0.3. If your samples are coming from Bernoulli 0.3 and you have seen 5 samples, which is 1, 1, 0, 1, 0. So what is the probability of happening this particular event?
Yes,
what
sir.
is the probability that x1 is 1, x2 is 1, x3 is 0, x4 is 1 and x5 is 0? It is given that the samples are coming from Bernoulli 0.3.
Yes, sir.
So all are independent.
Then we will just multiply.
Okay, multiply,
individual.
0.3, 0.3.
0.3 cube.
Is the
cube
product
into 0.7.
So whatever is this
square.
Product of
0.3 cube into 0.7
0.7 square.
So that is what it is.
Okay.
Okay.
Got it, sir. Yes, sir.
Yeah, here either theta can take two values. Either theta takes 0.3 and 0.7. use, in order to find this thing P of S, which is P of S, use the total law of probability. So what is total law of probability? Stats 1. Let's see how many of you remember stats 1.
Yes, summation of all the
Summation of
total
whatever
probability.
P of S. You want the overall.
Correct.
P of S is P of A by S.
Summation of all the cases.
Yeah, correct.
P of S by A into P of A plus P of A complement S.
So you have, let's say, I will try to give you some more intuition. This is, let us say, this is some B. Okay, some event B, and inside this event, A1, A2, A3. Okay, so this is complete full circle. Outside circle is B, and inside there are 3 events, A1, A2, A3, which are independent, like which are mutually exclusive, not the independent, which are mutually exclusive. A1 is different from A2, A2 is different from A3. So if it is like that, then you see P of B can be written like this: P of
B. Probability of B given A1 into probability of A1 plus probability of B given A2.
Okay, we will derive that, but you see P of B can be written like this:
A1 B, sir. Yes.
So can you use the earlier notation, sir? This is confusing.
Huh?
Can you use the earlier notation?
Intersection. It is intersection. It is
just the intersection.
It is pre-step. Then only that notation will come.
So B, I just
no. I would actually you are giving like probability of B.
You mean the last notation that you used?
Yeah, the previous one.
The multiplication notation.
P of B given A1. This one.
Conditional probability.
Yes,
I will give that. We will go there.
Okay. We will reach there only.
So P of B, can I write it like this? P of B intersection A1 plus P of B intersection A2, P of B intersection A3. See, if it is mutually exclusive, I can write it like this. It's the sum of probabilities.
Yes, sir. Yes, sir.
Now you see P of B intersection A1. Can I divide it by P of A1 times P of A1? Can I do it?
Yes.
I'm just dividing it with multiplying probability of A1 and dividing it by probability.
Yes, sir.
Same thing, probability of A2 divided by probability of A2. Probability of A3 divided by probability of A3. Okay. So observe this thing. What is this thing?
Probability of B given A1.
Correct. Probability of B given A1, which is probability of B intersection A1 divided by probability of A1 times probability of A1 plus probability of B given A2 times probability of A2 plus probability of B given A3 times probability of A3. Okay. So this is what law of total probabilities. It's the sum of mutually exclusive probabilities. So use that, and in order to find P of S, it is probability of S given theta is equal to 0.3 times probability that theta is equal to 0.3. Here the notations are different, that's it. So this S theta, so these are all events. You can always relate it to events. So this is one event, this is another event. So we want a P of S, bigger event. So P of S given some event A1 times probability that A1, P of S given A2 times probability of A2. So you can see A1 and A2 are mutually exclusive. 0.3 and 0.7 are mutually exclusive events. theta takes 0.3, it cannot take at the same time 0.7. So you can understand this part. So just the computation. What is this? Just take out 0.3 whole square and 0.7 whole square common, and also 0.5. You will get 0.5 times 0.7, 0.3 square, and there will be 0.3 left here, and there is 0.7 left here. This will sum up to 1. So this will be like 0.5 into 0.7 whole square into 0.3 whole square. So you got the P of S, and you got P of S given theta 0.3. So you know this value, this value, this value also. It is given. We got 0.5 into 0.3 whole square into 0.7 whole square. So this is what you get. So this will get cancel, and we will get 0.3. Probability that theta actually takes 0.3 now is actually after seeing the samples. So the probability that theta takes 0.3 is actually equal to 0.3. So now you see the posterior distribution is changing. So initially it is theta uniform between 0.3 and 0.7. But now probability that theta takes 0.3 is 0.3, not 0.5. Got changed after looking at the samples. And when you compute probability that theta takes 0.7 given yes, the probability that theta takes 0.7 given yes. So what this will be, it's actually either 0.3 or 0.7. Probability that theta takes 0.3 is 0.3. That means it will be actually 1 minus 0.3, you will get 0.7.
0.7. Yes, it will be
You can do
0.7.
directly. Even if you compute, you will get the same value. It's not like you will get different value. But also there is some smartness you should use. We know that theta takes values in between 0.3 and 0.7. And probability of theta taking 0.3 you computed after looking at an event is 0.3. Then the complement event is 0.7. Theta takes value 0.7. So therefore the probability that theta takes 0.7 given S will be 1 minus 0.3, which is 0.7. So now you see our posterior distribution, whatever our posterior distribution is. So prior distribution, we have theta to be uniform between 0.3 and 0.7. But our posterior or the updated after seeing the samples, theta is not actually uniform. It is 0.3 and 0.7 with probabilities 0.3 and 0.7. Okay, so it got updated after seeing the samples. In between, what happened? We looked at the samples, which are samples are 1, 1, 0, 1, 0. So if the samples are like this, the posterior distribution got updated according to this distribution. So we are considering this samples also into the picture. So what if the samples are different, like 0, 1, 0, 0, 0? If the samples are different, maybe the posterior distribution will also change, right? So what if the samples are this? What will be your P of theta is equal to 0.3 given S?
It will be 0.3 into 0.7 raised to 4.
Right. So let's write it. If you can't write it directly, write it with formulas, you know.
Okay,
divided by P of S. So P of S is anyway constant, whatever the value you got above. No, I don't think. Okay.
So it will be
So
changing.
Yes, it will be changed.
Here, point theta is equal to 0.1.
So this is 0.7
0.3
power 4 times 0.3
into 0.5
into 0.5, because our prior
So theta is 0.1, 0.1, that I didn't get again. That's confusing to me.
Which one is 0.1?
Probability theta is equal to 0.3.
That is 3.
Okay.
0.3.
Okay. So P of S given theta is equal to 0.3 is this, and probability that theta takes 0.3 is 0.5. So this is what our prior assumption, estimate, prior distribution. And P of S, if you compute, P of S will be something like P of S given theta is equals to 0.3 times probability that theta is equals to 0.3 plus S given theta is equals to 0.7 times theta is equals to 0.7.
Yes.
Okay, so this is something like 0.7 whole to the power 4 into 0.3 times 0.5 plus, and this is something like 0.7 times 0.3 whole to the power 4 times 0.5. So I am writing it directly. Just observe how I am writing it. Just so we know the theta, we are computing the probability that this particular event happens. So this is something like 0.3 times 0.7 times 0.5 of 0.7 whole cube plus 0.3 whole cube. Correct?
Yes, sir.
So what is 0.7 whole cube? 7 cube.
0.249. 0.249. Sorry, sorry.
343.
Yes, 3. Yes, sorry. Yes.
Yes, 0.343.
Okay, this is 0.7, 0.5, and this is 0.343.
Yes. Plus 0.027.
Yeah. So if we add those both, what will it be?
0.37.
Correct. 0.37. So now that you have P of S, you just substitute P of S as 0.7 times 0.3 times 0.5 times 0.37. So this. So what are we going to get? We are going to get 0.343 divided by 0.37. So what this will be? Somewhere around 0.9.
Yes, sir.
Very much near to 0.9. So you see, now that I have observed more number of zeros in my sample, I can conclude that the success between 0.3 and 0.7, there is a huge probability that theta actually takes 0.3. When you compute probability that theta takes 0.7 given as, it will be very much lesser than 0.1. It's actually less or equal to 0.1, I guess.
Yes.
Okay. So you see what this tells you, posterior distribution, what this tells you, after looking at the sample, out of my 5 samples, 4 samples are failures, or I have observed 4 tails and only 1 head. So the probability of getting head between 0.3 and 0.7, there is a huge chance that probability of success is actually 0.3 than 0.7. If it is 0.7, I need to see more number of ones in my sample, right? I have to see more number of ones. So after looking at the sample, my distribution got changed like this. So what it posterior distribution is now?
0.3.
Yeah, theta is actually between 0.3 and 0.7. There is a high chance of getting 0.3 and very low chance of getting 0.7 because I observed samples to be 0, 1, 0, 0, 0. So with respect to these samples, the posterior distribution changed. Okay.
Sir?
Okay, sir, got it.
So earlier it was 0.7 and this time it is becoming 0.3, right? So
because sample is changes there.
Yeah, that got it, sir. So again it brings a fundamental question. Hello, sir, am I audible? That how many samples to study and what to conclude?
How many samples to study is
like in earlier cases
for understanding we study only with 5, 10 or maybe 20.
No, that was one set of 5 samples with 3 ones and 2 zeros, right? So we got our probability 0.7. This was another set with 1 1 and 4 zeros. I am getting theta as 0.3. So should I take the average or how should I conclude about my...
See, you are not going to repeat. See, these are only 5 samples, so you are saying that I will repeat it. Okay. You are not in real life. You are not going to deal with only 5 samples. You will extract some 100 or 200 samples out of it. Okay, by taking not even 100, more than 100. Now that we have computers and everything, so computation we don't take much time. So I can take 100 or 200 or 300 samples out of my distribution and look at the, after looking at the samples, I will just compute the posterior distribution.
Correct.
Then I will conclude something. So once I get this posterior distribution, so that is what I am telling, right? Now again you observe one more sample.
Correct.
And this is maybe posterior distribution 1. Okay, now this posterior distribution turns out to be your prior 2. So this is your prior now. And take another sample and update this posterior distribution and you will get posterior distribution 2. Okay, understand? Connect prior, you take a sample, you will get posterior. Now take that posterior, you have observed one sample. Now take that posterior as your prior and take one more sample. And again you will get another posterior and you can take one more sample and you will update. Every time it will get updated only.
Constantly updating it.
It will update. It won't deviate from the original distribution. It will actually give better and better approximation to the distribution. Okay.
Sir?
What we do, prior, take the prior, look at the sample 1, posterior 1, you will get the posterior distribution. Now posterior distribution, take it as the prior and take the sample 2. So what you get is posterior 2.
Correct.
So like this we proceed. Okay. So this is how we have computed. If you throw a die, the probability of getting one number on it is 1/6. So actually we start with taking uniform, not uniform. Maybe you can start with anything. Like let's say 6 has high percentage of like 0.9 and getting 5 you have 0.01, 0.4, any distribution you start with. You just look at a sample 1 and update your posterior, and later you look at the sample 2, update your posterior 2. By repeatedly doing this simulation, ultimately we reach out very much nearer to the uniform distribution, and we conclude that each of them will have equal chances. And you start with uniform and you look at the samples. You can take the prior also, like uniform between 1 to 6. And maybe one sample, if you observe one sample, like maybe you throw die 10 times, you got 1, 3, 6, 6, 4, 5, 3, 2, 3, 4, 5, 6, 7, 8, and 1 and 3. So you observe this sample. So depending upon this sample, so this is a Bernoulli, correct? More than 1. So die comes under Bernoulli. So this is how it will be. And you know the sample, you have the prior, you update the posterior and take sample 2, sample 3, sample 100, sample 200. After so many iterations,
Hello, sir.
Hello.
Hello? Hello?
Yes, sir, you
Hello.
are audible.
Yes.
Sir, you are audible now.
Okay, thanks. So, where did the connection lost? I was explaining and suddenly it got lost.
The die case said that, you know, how we achieved. So we rolled it 10 times. And then we were writing some examples 1, 1 and 2, 3, 6, 6.
Okay, okay. So yeah, idea is that. So that is how we do.
Your screen is also not visible.
Yeah, I will share it. Let me get co-host access. But yeah, on top of it, what you should understand.
You will kicked out also, sir. After 2 hours, you'll be losing your connection.
Yeah, but it is not 2 hours yet, right?
Yeah, 15 more minutes to go.
I was ready with the 2 hours thing, but this gave shock to me by logging out before 10 minutes.
The test case.
Just 2 minutes, okay? Let me get the co-host. Meanwhile, what I'm saying is, on top of it, what you have to understand is, in this whole week, what we are going to do is, we take some prior distribution to our parameter, we see a sample, we compute the posterior by considering sample considering sample means likelihood. Okay. So considering sample means you compute the likelihood of that sample, probability of happening that sample is what likelihood means, and times the prior. Okay, that you will get the posterior. So once you get the posterior distribution, so every distribution have some mean, variance and everything. Whatever the mean of that posterior distribution is, that is what our parameter estimation. In this whole week, that is what we do, but for different examples.
Sir, one quick trivial doubt, sir. Like till week 9, whatever we have studied, we assumed, or the assumption was that, you know, population parameter is constant, right?
Yes, correct.
And all about samples like sample mean, sample variance, sample proportion, we treated them as random variable, right? But this is a major change in Bayesian, that we are considering population parameter also as a random variable, right?
Correct.
So in subsequent lecture number 3 or 4, even 2, we came to know that as sample size increases, right? Then my posterior mean is becoming, you know, converging towards my ML itself, right? As sample size increasing in lecture number 2, professor has shown that as sample size is increasing, my posterior mean is becoming more or less close to my ML estimator.
ML estimator.
Yes.
Okay.
So my question is that, then what is the utility of Bayesian, you know, Bayesian like this concept, like where we are treating population parameter as also random variable, and then the second question, the second follow-up question is that on what basis we are defining prior, like where to take uniform, when to take geometric, when to take, so these two questions are there, sir.
No, that convergence, I assume that convergence happens only in case of certain situations, like if you are
when n increases, when n tends to infinity, that's what professor is saying.
Yeah, only in normal and certain cases, right? If your prior is normal, but if let's say your prior is geometric or something like that, then it doesn't necessarily converge.
But don't you think that in real life we deal mostly with normal distribution?
No, not necessarily. It depends. If you're counting, let's say if you're estimating the number of people who walk into a mall, then it cannot be normal.
Yes.
Correct.
Okay, so that convergence is mainly for normal distribution.
Certain situations, not everywhere.
Certain situation, as one of the condition was that n is increasing, or my sigma 0 is also tending towards infinity.
Correct. So n is increasing when you take theoretical samples, then you can make n infinity or whatever. You can make n very large. Let's say you're actually collecting data on ground. You can't talk to more than 150, 200, 300 people, right? Then n is not very large. Then it won't converge. Because the more people you talk to, the more money you have to spend, the more time you have to spend, so on and so forth, right? So you can't do that. In real life, you'll deal with 150, 200, 250, 300 people. If it's, let's say you're talking to them. Of course, if it's IoT data and things like that, then you have infinite amount of data, but not everything is like that, right? So it only converges in certain reasons. What I understood of the Bayesian thing is, there's a certain prior you assume based on historical understanding or general common sense or expert opinion, whatever. Then as the data comes in, you update your prior beliefs.
Okay.
I have a question which is going back to what you said earlier and also the law of total probability which you showed. In that you have three possibilities, A1, A2 and A3.
I'm sorry to interrupt. Can you show the screen? Your screen is blank, so I'm not able to see.
Yeah, I didn't get the co-host access yet. I'm trying them. Let me get the co-host access. Yeah, Ravi.
Yeah. So what I wanted to ask is, in uniform, the prior that you're assuming, or we are starting with, we have two possibilities. Can we have likewise 3 and 4 possibilities, or is it not accounted for?
It is.
What? It is accounted.
Yeah,
okay.
Possibilities.
Okay. Only for computational simplicity, we're keeping it at 2.
Yeah.
Okay. Okay.
I think if we take 4 values, then each one will have a probability of 0.25 like this, if we are taking uniform.
Okay. So, did everyone get the idea of what week 10 is? Like what I said? So, basically, we do this thing only.
So, if time permits, could you please throw more light on utility of Bayesian, if time permits? If time permits, you can throw some light on utility of Bayesian. Utility.
That is 10.4, I think, sir. I think, but how to find the estimation actually. I believe so.
No, I'm not talking about estimation. I think that utility, like why we shifted all of a sudden from that MLE and ML estimator to Bayesian estimator. So, what advantage it carries over MLE and other one?
Can everyone see this particular question
Yes.
on the screen?
Some sort. Yes.
Okay. So which one you feel like everyone? I'm asking everyone in this session. Which one is a better estimator for the parameter? Any distribution, whether it is method of moments estimator or maximum likelihood estimator or Bayesian estimator.
So it depends. Now, for certain things, MME is better. For certain things, Bayesian is better. That's what professor said in his lecture. He gave some examples wherein MME was fitting, but Bayesian was not fitting, and sometimes Bayesian was fitting, but MME was not fitting.
Okay. You are saying that it depends on the data or situation.
Yeah, MME. I remembered MME and ML. That question was between MME and ML, but I think Bayesian is always better. That's what I think. I'm correcting myself.
If there is a number of samples are which many of samples are there, then Bayesian is equivalent to MME and ML, whereas Bayesian is is somewhat different.
Yeah, and one more, I think one more plus point of Bayesian is if we don't know the parameters, then Bayesian comes handy. But in case of MME and ML, we need to know the parameters. That's what I think.
Okay. Anyone? See, I'm just asking your opinion. Okay, whether it is correct or wrong, there is no correct or wrong. I'm asking which one you feel is better estimator.
If there are two unknown parameters, then how will Bayesian work, sir?
If
there are two unknown parameters, we have to compute those two unknown parameters. Then how will the Bayesian
two unknown parameters? How will
the Bayesian estimator work out?
How is MME and ML are working out?
No, not MME ML, the Bayesian estimator.
Okay. How will this work? So if it is from normal, maybe mu sigma square, you don't know what is mu and what is sigma square. How to estimate Bayesian is your...
Yes.
So before what we did? Method of moments and ML?
We found the first moment and second moment for MME. And for
And then
ML,
compare with sample. Compare
yes.
sample.
Okay, compare with sample, and we estimated mu.
And then in terms of mu, we
In terms
estimated
of mu hat, you estimated sigma hat.
sigma.
Correct?
Right.
Right. Here what we do? The same thing. So you know beta, right? Beta also have two parameters.
Yes.
Okay. So how do you estimate alpha and beta? So you see, even in mu, we say mu, you know mu, let's take mu follows something.
Yes.
Okay, mu follows some maybe uniform between 0 and interval 0. Okay. You take something like flat prior, you take flat prior.
Yes.
Okay, then you observe the samples. Okay, I think in this particular course what we do is we give you sigma square, I guess. There are questions in normal, I suppose.
Yes, sir. It is explained one scenario it like this. It is. In one scenario, they given sigma square only mu is unknown.
Mu unknown, sigma square known.
Sigma square is known, right?
Yes, yes. Professor said that in this course we'll discuss this case only. There are all the permutation combinations possible, but we'll discuss this one only.
Yeah. See, I think as of now we deal with only one parameter, even though the distribution has two parameters. What we do is we try to understand one thing by keeping other thing as known, and we try to estimate one particular parameter. That is what we do. I think if you don't know that, what we treat it is, we treat sigma square as constant, one constant, some random constant, and we don't treat it as a random variable. We take it as a constant, and we try to estimate mu, and then what we do is we try to estimate sigma square by taking a posterior distribution of mu, and by calculating posterior mean of mu. And with respect to posterior mean, what we do is we calculate the posterior standard deviation. Okay, that is one way, but don't worry about those things as of now. But understand from, see, this is somewhat next level. Okay, understand the first level. So how to estimate one particular parameter? If you know how to estimate one particular parameter.
No, the question came in my mind because you asked what is the best, better method between MME and ML. So I thought like in Bayesian it will be difficult if we try to compute two parameters.
Okay. But okay, whatever we know, just taking those things into the consideration, this is my question. And most probably the answer will be like, it depends on the situation, which one is more helpful. Okay.
One query over here. In case of MME and ML, it's like the fixed parameter, right? In case of Bayesian, it is a random variable, right?
Yes,
so if it's a random variable, MME and ML will not help, huh?
MME and of course, right? In MME and ML, what we do is we treat that parameter as a constant.
Yeah, right.
And we
but the parameter will always be constant, no, sir?
Yeah, parameter will always be a constant.
Just we in Bayesian we are just taking for our convenience that is random variable.
No, not for our convenience. Bayesian actually said that parameter estimation, when you are estimating a parameter, how can parameter be a constant?
Yes.
So
means it's an unknown. Parameter is unknown. So we are taking a range.
Yeah, if it is unknown, how can you say that it actually takes only one value with probability 1? Okay. So he's arguing with this MME and ML frequentist estimators is like, without taking some distribution to parameter, how will you compute something based on just samples? So one particular sample, if you take one particular sample, how can that represent the whole distribution is Bayesian term. And many people argue, see, even in the lecture, professor might have said this.
But sir, ultimately Bayesian is also giving us a certain value. We are calculating the mean of the distribution.
Professor
So it
said,
will also be providing us a constant ultimately.
Ultimately, it provides constant. But what is the difference between Bayesian and MME is they don't treat MME and ML don't treat it as a random variable, and they treat it as a
Yes.
constant, and they don't take any distribution that constant, and they only by taking the sample, only by observing the sample itself, they will estimate the parameter. And what Bayesian says is, by looking only at the samples is a foolish thing. You should actually understand the data before with some knowledge and take theta to be a random
Yes.
variable and take some distribution and then observe the samples, and combining
Yes.
these two only I can conclude something, and some say this is bullshit.
So
Okay.
that means the Bayesian first studies the data.
Bayesian actually intuitively he will not study whole data also. He will intuitively see that the data is coming from
like this.
It will assume a prior. It will assume a prior
It will
distribution.
assume there will be some assumptions looking at the
Assumption.
data.
Correct.
So there will be individual differences in Bayesian estimate. Means some person might be using it differently. Some other person might be using it differently.
It is altogether different branch within statistics itself. This Bayesian statistics.
Correct. So that is what happens in real life also.
Yes.
However, how you see data may not be same thing that the other person sees the data.
Correct.
Correct.
Yes,
So you may see it in one way.
Bayesian
Someone may
leaves
see it
room
in
for
another way.
confusion.
Sir, that's quite reflective also. All the financial institutions predict the economic number differently. Even though there is a difference of 0.2, 0.3, but there is a difference.
So I'm having one
my,
query
Sir, where your
regarding.
quiz to?
Sorry.
My point of view was that Bayesian allows for taking historical experience and kind of giving some options even before you start. Right? Otherwise, the others don't. They assume just that it's some number and you estimate that from the samples. Here, there is a wriggle room to use historical experience and to understand, okay, it could be this or this or this, and what is the best.
Correct.
Right. So more data. I think Bayesian is updating as and when you get more and more data, you keep updating all your beliefs. Right? So that's
Updating the prior belief.
Yeah, prior with the data. Actually, Srikanth, sorry, just a digression. You don't have to answer now. But I had put on discourse this thing for which Professor Andrew also responded, which is I did the calculation using weak law and then I did one calculation using CLT. I was getting very drastically different results. I just wanted to be sure whether my calculations are right or am I making some mistake somewhere, because in one place I'm getting 2000, in one place I'm getting 385. That's a world of a difference. Right?
Correct.
Whenever you have time, if you could just look at it once, it will be helpful.
Yeah, we will look at it. This question was already asked by someone, I guess. I think Kavita or someone. They just asked this.
Actually, sir had answered that.
Yeah. So okay, I will look into it. Okay. More.
Oh, no problem. If it's answered, then because I had done the calculations, I'm getting very different numbers.
Correct.
Very different.
Whatever you got is correct values. So even I computed that on one session, I guess.
Okay.
One way we get something around 2000 or something. Are we correct?
Yeah, 2000, and the other option is CLT. It's 385.
Yeah, 385 is one thing. Kavita, if you remember, what values did we get? Like
values, I'm not remembering because I had asked a question that which one is better, and at that time he had responded that in certain cases CLT fails or in certain cases WLN fails. So there is no direct answer to that.
So what I concluded is we will give you what to find in which way.
Yeah,
how to
right.
Okay.
So I'm having one query regarding this the last lecture where he explained where he explained that we have to use that Monte Carlo type thing, like giving n equal to something. Now, if I'm not having any other sample, I'm having only one sample, and I'm giving n as some big value and doing that. So on that basis of the sample itself, the computer will generate the data, right? And do it. So in that case, if the sample is having certain outliers, the result is bound to be wrong, right?
If you have only one sample, see, yeah, Whatever you are saying is also an outlier case.
Meaning?
So not always like you will have only one sample and not a.
No. I mean that bootstrap
Hello.
thing is only that. Na, if I don't have any other data, like I'm having only one sample, and then I'm doing that Monte Carlo type thing, and I'm giving n as a very big number, and it will generate based on that. So in that case, my query was the computer will generate the data based on the sample, right? And in that case, if my sample itself, because since I don't have any prior information with me, and I'm having only that sample with me, I don't know whether how genuine that sample is. The result is bound to be wrong, no?
Bound
so
to
in
get
that,
some errors.
Yeah, I mean not wrong. I mean the error can be very high. So we cannot say that if n is very big, it is always that the result will be right. I just wanted to confirm my understanding. That's why I'm just asking.
It's like if your n is large, what it gives you better. It makes it better only.
So it is relatively better kind of.
Relatively better, correct.
Okay, got it. Okay, thank you.
And yeah, coming to this 10.4. So what exactly?
So before that, 10.3, you were so when you're going through this Bayesian formula, the one of the interpretation somebody interjected and then changed the notation. So I just wanted to complete the earlier notation, sir, which we didn't carry on from that point. Can you scroll up for that step?
Okay. Still.
No, further up. Yes, sir. Here, so just down, not this one. Let's scroll down a little bit. Yes, sir. So intersection, probability of P intersection A1 by probability. So we were actually wanting to do it in terms of this one, right? What was the one, sir? Probability. Okay. Probability B given A1. So this is this one. I have a question here because when I did the start one, I was clear with that, but now I just vaguely forgot that actually. So here, A1, A2. Can you just explain these couple of these two equations? A1, A2, A3 are disjoint, like independent.
Okay. Yeah,
B is there.
disjoint.
So how? Yes, sir. Sorry.
Okay, maybe A1 is this event. Okay.
Yes,
and A3 is something this event, and A2 is something this event. Now B is this circle.
Yes.
So I want to compute the probability of B of this circle, maybe. Okay. So this circle can be split into three different regions: A1, A2, A3, and all three are disjoint. Now I can write this B. I can split this B into three different regions. One is this, which is B intersection A1, and another is this B intersection A3, and another is this B intersection A2. Okay. As these are disjoint mutually exclusive events, probability of B, I can write it as sum of all the three events.
Yes.
So that is what I wrote: P of B intersection A1 plus P of B intersection A2 plus P of B intersection A3. Okay. And what I did is each term I just multiplied with probability of A1 divided by probability of A1. And probability of A2 divided by probability of A2, probability of A3 divided by probability of A3.
Yes,
now observe this thing. So probability of B intersection A1 divided by probability of A1. Again, this is conditional probability that B given A1. This will be. So this is nothing but probability of B given A1 times probability of A1. And similarly, the other two terms will be probability of B given A2 times probability of A2.
So sorry. So probability of B intersection A1 by probability of A1 is equated to probability of B given A1, right?
So that is what conditional probability is, right? Probability of A given
But
B is
conditional probability of A given B, or okay, here probability of B given A1 is probability of B intersection A1 into probability of B by probability of A1, right?
Correct.
So here, how does it work out here? Like probability of B, given A1 is probability of B intersection, probability of B1 into probability of, okay, probability of B1 by probability of.
Okay. So you just take a
probability of B, sir. The probability of B.
It's not that difficult, okay? If you understand this even law of total probability, it's not that difficult to understand.
But probability of B is missing, sir, actually. Both are probability A1, right? Probability of B we need to get as a second term.
Probability of B given?
Probability of B given A1 is probability of B intersection A1 into probability of B divided by probability of B. But here we are not getting the probability of B, right, separately.
See, what is P given P? Probability that A given B?
Probability of A given B is probability of A intersection B into probability of A divided by probability of B.
Why into probability of A? Why is this term coming in?
I'm looking at the Bayesian probability, sir. Bayesian formula from probability
that
of
is, it's not
doing
P of
different
A
events.
intersection B, then it will be like P of B given A times probability of A.
Sorry. Probability of A given B is probability of B given A into probability of A given by probability. Yes,
So
yes.
what is
I was sorry. I was referring to
this
this one.
this will
Yes, sir.
again be, this is probability that B intersection A or A intersection B. So you just see this A given B. So given B, what is the probability of occurrence of A event?
Yes, sir.
It's probability that A and B happens divided by probability of B.
Oh, okay.
That's it. Now this probability of A intersection B can be written like this: probability of B given A times probability of A. That is what it is.
Okay. So probability this is something which I missed. Probability of A given B is probability of B intersection B by probability of B.
So from there you will get, okay. So now I will take some.
Sir, the same question, sir. How we are reaching this mean and mode kind of thing in the same question?
How we are?
Mean and mode.
Which question?
The above question, sir. This question, the last.
This question.
Yeah. Asking for mean and mode, sir.
Okay. Now that you got the posterior distribution as this, like theta is between something, right? 0.3 and 0.7 with probabilities 0.3 and 0.7. So what do you mean by mode? What is mode?
Maximum number of occurrences.
Maximum number of occurrences, or which has higher probability. In this probability things, mode is like which has the highest probability. So among this 0.3 and 0.7 in our posterior distribution, 0.7 has probability 0.7 and 0.3 has probability 0.3. So the posterior mode will be 0.7. So the estimator is theta is 0.7. So 0.7 is the posterior mode.
Mean is just average of the concept. Mean is average of the both.
Mean, how do you compute the mean, posterior mean? So what is mean? Expected value of theta? Correct? So what is the expected value of theta? If the distribution is like this, posterior distribution is like this, what will be the expected value of this theta?
Multiply value with the probability.
Plus 0.7 to 0.7.
Correct?
Yes.
So this is the posterior mean. So you see the difference. Posterior mean. So what is posterior mean? This is just the Bayesian estimator. So we say theta hat Bayesian. So theta hat Bayesian says 0.58, which is different from 0.3 and 0.7 we took. What we thought is it is uniform between 0.3 and 0.7. But the estimator for theta we got is like something around 0.58. So by looking at the samples, we got this. So this is the estimator, Bayesian estimator 0.58. And this is posterior mode. So we don't much, there is no much usage of this posterior mode, but there is high usage of this posterior mean, which is actually the Bayesian estimator, which is actually the expected value of the posterior distribution. Okay, so this is what posterior mean means.
Could you explain bootstrap concept a little bit? Bootstrap concept a little bit.
Bootstrap, even I should again go back and watch it. Even I am not that sure about this bootstrap and everything. I just said, right, even I am in the running stage of Colab. Okay, but without Colab, I can answer you.
Yes, sir. Without Colab, sir. The concept part.
No, bootstrap, I am completely unable. I have to look into that bootstrap concept again.
Okay, then we can discuss on Sunday.
Yeah. So maybe I will discuss this. Yeah.
Sorry, go on, please continue. There's something different. So continue, please.
If there is any doubts, you can ask, or else.
I have a problem in 10.4 activity. Problem 3. I was not able to solve that. Thought you might help me.
10.3.
So 10.4. 10.4 problem 3.
Okay, 10.4 problem 3. In this lecture, right? In this lecture, problem 3.
Yes.
Okay. So, what is problem 3 in 10.4?
It's basically.
Is it related to additional lecture you are talking about, or the main 10.4 lecture?
Main 10.4, activity 10.4. AQ 10.4.
AQ 10.4 in the activity.
Yeah. Activity questions 10.4.
Okay. It's like question 3 means it is saying that to estimate the fraction of people P who support the construction of a shopping mall in the city.
No. Suppose one believes that her prior mean is point.
That is the second. So the information for question 3 is given above also.
Yeah.
Even you have to use that information.
Correct.
So okay, I will try to solve this particular question. Maybe this will give you the whole idea of week 10.
Yeah.
Okay. So initially what it says is to estimate the fraction of people. So fraction of people who support the construction of a mall.
Yep.
Of a mall in a city. A local newspaper conducted a poll of the city residents. Out of the 68 people in the sample, 21 supported the construction. So they have asked 68 people, and out of these 68 people, 21 supported for construction, and remaining 47 people didn't support the construction. Okay.
Yep.
So now what we say is, suppose one believe that her prior mean is 0.6 and prior standard deviation is 0.15. Okay. So she has been said that she has some prior distribution for P. For this P.
So someone has to mute something. Some noise.
What?
Someone has to mute, I guess, there's a background noise.
No, I don't think the noise is from my background, I guess.
Some shrieking, yes, shrieking.
Okay.
It's okay. It's all right. It is not disturbing.
Okay.
Please proceed, sir. Please proceed.
So in the prior distribution, it is given that prior mean or the mean of the distribution to be 0.6 and the standard deviation is given to be
0.15.
0.15.
Yeah.
And also we said that you use beta distribution as your prior.
Correct.
Okay. And what we asked you to find the posterior mean.
Yes.
Correct?
Yeah.
This is our setup and this is what our questions. Now, how do we proceed? We know the prior distribution. So we said that it is beta alpha comma beta, and we have given you the mean and standard deviation also. So what is the mean of beta?
Alpha by alpha plus beta.
Yes. So mean is nothing but expected value of prior is alpha by alpha plus beta. So which is given to be 0.6.
0.6.
Okay. And also, you know variance, I guess.
Yeah, variance is alpha beta by alpha plus beta square into alpha plus beta plus 1 is equal to 0.15.
So I hope I
whole
no
square.
need to prove this thing.
No.
You know how to.
No. Yeah. 0.15 square.
0.15 square.
0.15 square, isn't it?
Yeah, correct. So from here I will get alpha and beta.
Yes.
Correct?
Yes.
Now I know exact prior distribution, beta with some value and some beta, alpha and beta, known values.
Yes.
Now I need to find the posterior mean. In order to find the posterior mean, I need to find the posterior distribution of this posterior distribution, which is directly proportional to the likelihood times the prior.
Yeah.
So prior is something like f, some capital P of P. So what is PDF of beta?
Sorry.
PDF.
Okay. P into
so this is PDF, right? PDF
P power alpha minus 1 into
P
1
power
minus P
alpha
power
minus 1 into 1 minus P power
beta minus 1.
minus 1.
Yeah.
And what is the likelihood? Likelihood something is like
P into
so
again it will be this time it will be alpha plus 1. Oh sorry. No. It will be alpha and the way it comes out of the other two equations, that is from mean and variance.
this is likelihood will always be connected to the sample. Okay.
So sorry. Prior is the one I was actually mentioning. Yes.
Prior is this.
Yeah.
When
this will be P power 21 and 1 minus P power 68 minus 21.
Correct. So out of this 68 people, 21 supported and 47 not supported.
Correct.
Okay. This is something like, so supported people. So this is the fraction of supported people. So P power 21 times 1 minus P power 47. Right?
Yep.
So if you know the direct formula, I'm not lecturing for those who know the direct formula. You can use the direct formula, if you know. So the posterior mean will be something like alpha x1 plus x2 and so on to xn plus alpha divided by n plus beta. So that is what posterior mean, right?
Yeah.
For that you will get it from here. So you see this particular thing. Now this will be like, this is directly proportional to P
21
alpha minus alpha plus 20.
Yeah.
1 minus P
46
beta plus 46.
Yeah.
So you see this is something like P alpha
then I
plus
made
20,
a
1
arithmetic
minus
mistake
1.
somewhere.
1 minus P beta plus 47 minus 1.
Yeah.
So this particular posterior distribution, actually it is directly proportional to this thing.
Yeah.
If it is directly proportional to this, this is something like it is directly proportional to some PDF, which is actually the beta with parameters alpha plus 21 and beta plus 47.
Yeah.
Correct?
Correct.
So the posterior follows this. So if the posterior distribution follows this, what will be the posterior mean?
Yeah.
So posterior mean is actually expected value of this particular thing.
It's again alpha plus 21 by alpha plus beta.
Plus 21 by alpha plus beta plus 21 plus 47.
68. Yeah,
something like this.
Yeah, yeah.
So you can get alpha and beta values from here.
Yeah.
From here.
Yes. Yeah, there is arithmetic mistake somewhere.
Yeah,
I am getting 0.3092 for some reason.
Substitute those alpha and beta here. You will get the posterior.
Yeah. Thank you. Thank you. I just wanted to
this
verify
is what
my
we
procedure.
Correct. What we did actually, we did prior. We know the prior is given to us.
Yeah.
And also the sample is given to us.
Yeah.
By taking prior and sample, we found out likelihood and prior, and our posterior distribution is directly proportional to likelihood times prior.
Yeah.
And we will get the posterior distribution. From posterior distribution, there is some posterior mean, posterior variance, or whatever posterior mode. Okay.
Yeah.
So these things you can compute. So these are the posterior mean is the Bayesian estimator. So P hat of Bayesian. So this is the estimator using Bayesian. So this is what we do. The setup may be different, but the process is same.
Right.
Okay.
Yep. Thank you. Thank
So
you.
I guess you will get alpha value.
Alpha
5.8 or something. And beta you will get 58 by 15. You can cross check.
Okay. Once again, please. Alpha is 5.8.
Alpha value will get 5.8.
Okay. Beta.
And beta value you will get something like 58 by 15.
58 by 15. Okay. Thank you. Thank you.
Substitute. Ultimately, I guess you will reach to the answer 0.345.
Yeah.
Okay.
Yeah. Thank you. Thank you.
Yeah. And one more thing, is it there? I just wanted to address this particular question. Is the guy present here who asked this question? I think he is Nikhil.
No, but
Nikhil is here, right? Nikhil?
No, sir, I didn't.
You didn't ask this. So someone asked like why we divide it by 4 only. Why can't we divide it by 5 or 6 or 3? How many of you are there actually when he asked this question?
Yes, sir. This question was asked in one of the live sessions.
In one of the live sessions, right?
Yes, that's correct.
So here is the proof. So you can just post it. So what is the expansion of e to the power x by 2? Taylor expansion.
So it will be 1 plus then x by 2 by factorial 1 and the next square factorial 2 like this. It will go on.
Okay.
The odds will all cancel off. So
correct.
Okay, the divided by 2 comes there, so the x squared by 4. Okay.
So now you get 2 plus 2 times x by 2 whole square by 2 factorial. What happens is this odd terms will get cancelled out.
Yeah.
So there will be minus signs. Only the even terms will remain. Okay, like this. Now you take to the left hand side. You will get 1 plus x square by 4 divided by 2 factorial plus x power 4, or you see x square by 4 whole square divided by 4 factorial, like this. Okay. And you see the expansion of e to the power x square by 4. This will be something like So you see this?
Yes.
You just compare. This term is equal to this term.
Yes.
But
Okay.
this term is greater than this term.
Yes.
So term-wise comparison. So this particular term is greater than this particular term. Correct? Dividing it by 2
2 and by
factorial.
4. Yes, yes.
By 4 factorial, this value is lesser than this value.
Yes, yes.
So it will be like 1 is equals to 1, but the next terms x square by 4 by 2 factorial is less than or equals to x square by 4
by 4 factorial.
1 factorial.
Sorry, 1 factorial. Yes.
Yeah. And similarly, x square by 4 by whole square by 2 factorial is less than or equals to x square by 4 whole square by 4 factorial. So like
no, sir,
this.
here sir, on the left hand side will be 4 factorial.
Yeah, correct. So this is 4 factorial and this is 2 factorial.
This is 2 factorial.
So and
yes.
so on. If you add all this, the left side it will be like e to the power x by 2 plus e to the power minus x by 2 divided 2, and the right side is actually e to the power x square by 4. Okay. So this thing, dividing it by 4, we can actually prove by comparing the terms. And divided by 5 or divided by 6, it's hard to prove. Even that is also a bound, but it's difficult to prove. So getting this is difficult. So I will give the timestamps of this today's live session. So if he is present in any of the lectures or in your student groups, just inform me that at the end of this session, I have actually given the proof. Okay. I can't recollect who asked this question, but someone asked this question.
Yes, someone asked.
Yeah. So this is how we can actually prove the bound. This particular bound can be proved, and proving this bound is difficult. So there is no direct proof for this particular bound. So ultimate idea is to get bound. So we will bound with this.
Sir, sir, sorry, just I lost the connection. So yeah, we started adding. Then on the left hand side we got e to the power x by 2 plus e to the power minus x by 2. Okay.
Divided by 2.
And then on the right hand side it is coming.
So right hand side it is e to the power x square by 4.
Okay.
So we got an upper bound. That's it.
Okay, so this is the rationale behind it.
Yeah. Okay, then so see, nothing week 10 I don't have anything to discuss because Nikita has discussed it clearly, I guess, in the previous session. So it's just the computation part. Week 10 has there are no new concepts, only one concept dealt in week 10. That particular one concept is you take prior, you look at the sample, you compute the posterior. Nothing new, nothing different also. So this is what we do in the whole week. So that is why also I don't think this takes much time to understand. So that is why this Sunday what we did is we have kept a session for week 11 so that we can discuss week 11 contents also combined.
It's okay, sir.
Nothing to do with solve with us of week 10 is what. So we have to keep that session. So that is why we had that session just before the assignment deadline. But before that also, say the deadline for week 11 is on 24th. Okay. You don't get a lot of time to, once you complete week 10, then we sit for week 11. That is not how you should do. So for
So
these 2 weeks,
this dilemma can be simplified. If you are coming on Sunday, sir.
Yeah, I am coming on Sunday.
Then let us discuss week 11. Otherwise, we'll go for solve with us. If you are coming, then it's okay to discuss week 11, sir, so that we will get some conceptual understanding.
Also, see, why we are having this session is because the deadline of week 11 is not far from week 10.
Yes.
Okay, if you are coming, then fine, sir. We can discuss week 11.
Okay.
Sir, do week 11 concepts require week 10 knowledge? Does week 11 require?
11, I think no. It doesn't
So I
require
mean,
that
like,
much.
is it okay to skip week 10 and go to week 11 direct from week 9?
But one thing you have to take from week 10 is actually the parameters is not a constant. Parameter is actually a variable, and we actually test the hypothesis there. So I will give you that this parameter takes this value, and you will say that you will suspect that it is not equal, or it is less, or it is greater. So difference between you and me, we will test whichever which one is correct. So that is what we do. So in order to understand this, you need to understand that that particular parameters are not actually constant, it actually random variable. So that is what you have to take away from this particular week.
So which week 10 lecture will that cover, sir?
The very first lecture of week 10 will cover that thing.
Okay, sir. Thank you.
Okay. So that is what you will take away. What we do is complete statistics. What we do is we test the hypothesis. We will take one hypothesis, and what we do is we try to prove that hypothesis correct or wrong or something we do by taking some test static, some samples, and comparing between two things. So either you or me. So I say my speed. So I will bowl with speed at an 135 kilometer per hour, and you suspect that you can't bowl that speed. Maybe it is lesser. So I will bowl some random 10 balls to you, and you will, by taking that sample, we will conclude whether your hypothesis is correct or my hypothesis is correct. So whatever I said is true or whatever you said is true. So that comparison happens. So for that you need to understand that whatever the parameters are there, the parameters are not constants. It's actually a random variable which can take any values. Okay, some values, not any values, some values in between. Okay, that is the takeaway. So week 11 has many concepts to discuss.
Yes, sir. Yes. That's right, sir. If you are coming, then we can discuss week 11.
Yeah. So
that
more
will be
focus
helpful.
on just complete week 10 quickly. So only one concept, it doesn't require much of it. So complete week 10 quickly and move to week 11 and watch the week 11 lectures and come on Sunday. Okay, we will discuss.
Sir, I have just a couple of things quickly, sir. Sir, same, sir. Sticking on with week 10. Looking at video 10.3, actually, in notations, I have such like confusions are there for the probability distribution for x1. I mean, like x1 equal to probability of x1 taking the value x1 into probability of x2 taking the value x2. Same like estimation with the samples. So I was just confused, like why not take x as a common one, x taking values x1, x2, x3, right? So x1, capital X1 taking small x1, capital X2 is making small x2. So there's a missing link for me there. I'm not able to make out.
One instance of samples.
Sorry, then?
That is one instance of samples. Can you be more precise? Which lecture you are talking about? 10.1 or 10.3?
Yeah, 10.3. 10.3. If you can open that video 10.3 timestamp 810.
Okay, just a second. Let me open. See, and the other people you can leave. Okay, we are done.
Okay. Thank you very much. Good night.
Thank you, sir.
Thanks a lot, and have a good day.
Sir, I have a last question. After this question, I have one.
10.3.
If you have last some questions, you just hold on. So those who are done, you can leave. So this is week 10 doesn't contain more concepts to discuss. It's about only problem solving in different. So maybe geometric or normal, or the prior is different and the posterior will be different. So 10.3. So that's it. Okay.
10.3 timestamp around 10. I'll tell you the timestamp. Timestamp is 8:10. 8:10.
1 second. Okay, you can able to see the screen, right?
Yes, sir.
2/3.
So this thing is it?
8 and 10 seconds.
How many? 1.
8 minutes 10 seconds.
8:10, right?
Yes, sir.
Okay, this is 8:10.
Yes, sir. So the probability, instance of when you look at the maximum likelihood one, we are able to see that, yes, sir. So here number of zeros, n naught number of zeros, and the sample number of ones in the sample n1. So the probability b x1 equal to x1, x2 equal to capital X2 equal to x2. So I was just my mind was looking at that. Suppose x is discrete. The question says suppose x is a discrete random variable. So I was thinking like, why not have x as x1, x, like we did it in the earlier cases, right? So
your x1,
yeah,
x2, all x1 can be written as x.
Yeah, that's what I was thinking. It was confusing to me. So.
Okay, it's not actually confusing. It's actually gives you more clarity. This x1 is the first sample. Okay. Capital X1 is the first sample. X2 is the second sample. Like this, xn denotes the nth sample. Okay. All these x1, x2, xn comes from x. So these are IIDs of x.
Okay.
So if you take x, everything to be x, so which one is the first sample and which one is the second sample? How do you differentiate it?
Oh, okay.
Okay.
So here, for easily understanding the distribution here, the samples, that is basically matching with the notation, right? X1 is here, let's say 2. X2
X1
will be
is
2.
actually 2.
X2 will be 2.
Actually 2. Yeah.
Okay.
X3
Instances. Okay.
Yeah. This is one instance.
Got it, sir. Got it.
So
And
small x is the sampling. So small x1, x2, xn is the sampling. Okay. One instance. And that is what the likelihood is. So this gives you more clarity. That's it. X1 means the first sample. X2 means the second sample. Like this, xn means the nth sample.
And the small ones are actually the values taken. 2, 2,
Yeah.
0,
So in that particular instance, x1 takes 2. 2 denotes small x1.
Yeah, correct. And the next one is yes, sir. So in one of the problem solving, not that lecture. I think it's 10. Oh yeah, I think so. It's 10.3. Yeah, 10.3 only. So in calculating, there are 3 problems. The second problem, which was geometric distribution for IID samples, wherein the second part is maximum likelihood and the maximum likelihood. So in this case, obviously, like I said, we are calculating the maximum likelihood from the probability p power n 1 minus p power x1 plus x2 and so on to n x by xn minus n. And then after that, we are doing the log and then equating it to 0 so that we get the maximum likelihood estimate. So then my question here is, for the value of the likelihood when we are using the probability function p power n into 1 minus p power x1 plus x2 plus x1 plus xn minus 1 minus 1. So here and not okay. So what I actually have written here in my notepad. Okay, yeah. So we are using the likelihood as the p power n 1 minus p power n minus 1. 1 minus p power x1 plus x2 and so on to minus n, right? So I was looking at the ml, that is the estimate of ml, which is n by x1 plus x2. Why not this? But why are we using L? Maybe it's very basic doubt.
Probably. Why not?
Why not we use the likelihood as from the estimate p ml cap, which is n by x1 plus x2 plus and so on to xn. Instead of that, we are actually taking p power n. So I was just confused between these two. You got my point, right? Like
this p power n, is it?
Yes, sir. That p power n. Instead of that, I thought we should be using the one which is given below, P equal to n by x1 plus x2. Yes, sir. For maximum likelihood.
I am not getting one. See, this P power n, this is likelihood function, okay?
Yes, sir. Yes, sir.
This is not the maximum likelihood, or this is not the estimator. This is just the likelihood function.
Yes, sir.
And we try to maximize this. Okay?
Yes, sir.
So for which value this takes maximum value is for the value of P to be equal to n by x1 plus x2 plus xn. This particular function takes the maximum value.
Yes, sir.
Okay? So this particular P becomes the maximum likelihood estimate. So nothing P power n. P power n is in the function.
Okay.
Okay. And this particular P value, what we get is the maximum likelihood estimator.
So can you just probably go to another a few seconds into the front, like scroll by another 5-10 seconds ahead? No, you're going back. I'm sorry, going forward. Yes. Here, sir, this one. So this P cap ML, that is maximum likelihood. This is we are deriving this. We are getting n by x1 plus and so on to plus xn.
Okay.
Which is same as the method of moments, but I was comparing this result with the likelihood L above. So I was thinking this should be the one rather than the L. Maybe I didn't get the basic. Yeah.
No. See, this particular L is actually a likelihood function.
Yes, sir. Yes, sir.
So it is defined as the product of the probabilities.
Yes, sir. Yes,
of
sir.
that particular sample.
Okay.
So it's like pi I to n, I1 to n, probability that xi takes value small xi. So that is a product of some probabilities. So that is the likelihood function we define.
Yes, okay.
Okay. This particular first term, 1 minus p whole power x1 minus 1 times p, is the probability that x1 takes x1.
Yes,
so
sir. Yes,
for the first sample, the value is x1. So for example, we observe small x1.
Yes, sir.
So what is the probability that first sample takes value small x1?
X1, yes, sir.
So this is the probability.
Yes, sir.
And likelihood function, we define it as product of those all probabilities. Or if you have n samples with you, it will be like product of n different terms like this. Okay. So this is the first.
So here P is a probability, like I mean the next term P is actually for the
success. See,
success.
If it is see, this is geometric P.
Yes, sir.
So if your first sample is x1, what it tells you, x1 minus 1 times failure, and the x1th time is the success, right?
Come again, sir. Sorry. For the geometric function, yes,
geometric distribution.
Yes, sir.
So how will be the samples look like?
Yes, sir. Oh, okay. Okay.
So geometric means it's actually we are looking at the first success.
Yes, sir. Yes, sir. Correct.
So if your small x1 is something like, let's say 6,